How is everybody doing today? Let's see. How are things going? Oh, man. It's been a bit of a crazy day. We're going to be learning circuits together today. For better or worse. So we're just going to send it. I am talking with Tim from TH3D, so we are hanging out. We'll get some crab rave. We'll let you guys get in, get settled, get a snack or two, because this one might be a bit of a long haul. Sorry, just waiting for people to get in, get comfortable, get hanging out. Again, we're gonna be learning circuits. I think we're gonna end up doing KiCad, but I'm gonna show you some of the ones that I've been looking at for the past week. TLDR, I kind of hate them all, because none of them are that simple. And I truly wish there was like a Tinkercad for circuits that I could then also get manufactured, because there is a Tinkercad for circuits. Victoria is here. She's just mildly off camera. Sorry. But there is a Tinkercad for circuits called Fritzing, but it doesn't produce Gerber files, which is what you need to manufacture PCBs. So it's gonna be a thing. We're just here. We're gonna make it happen. I don't know. We're just gonna make it happen. But yeah, this should maybe the last, if not second to last, definitely second to last video, unless something goes wrong, series on the Osmo Pocket Ammo Can holder. I have yet to 3D print the parts. I wanted to get the circuit boards done today to figure out, you know, will everything fit the way that we had it last week? And if it does, you know, with the circuit boards and all that, then we'll go ahead and we'll 3D print the parts. We'll get some circuit boards on order. And I'm guessing next week we might have to maybe have something in between, because I'm not certain if next week it's going to work, like, properly. I love how, so I'm talking with Tim from TH3D right now on Discord, so sorry if you guys can hear the typing. Tim is telling me, don't make a custom circuit board, just buy 90-degree mounts and use cables. I know, but what's more fun? Fun, he says. Yes, I'm going to try to do this, and I want to bring you guys along for the ride. First, though, we have to get some parts. Hilariously, I'm gonna switch to Little Grant real quick. Let's go to Tiny Grant. Let's bring up Fusion 360. Hilariously, I've been looking for USB-C male connectors, and actually the connector that I would love to use is right here. The problem is that I can't get these assembled. So PCB assembly. Let me turn down the music just a hair. PCB assembly is where a company does all of this for you, and you just get a perfectly done and ready to go PCB. which is what I would like. Now, I can solder. I can actually solder quite well, and I have full faith that I could solder to these tiny little pads here. But I don't want to, and I want to try out getting a PCB manufactured from scratch. I think that would be a lot of fun. So we're gonna do things the hard way, because my 2 business degrees definitely know how to design circuits. That's me joking, because I have not a damn clue what I'm doing. I have been trying to learn circuits since last Wednesday. After our live stream, I kind of started. I got, you can see they're all open here. We've got Eagle, we've got KiCad, we've got Easy EDA, and that's OBS for the live stream. Here, I'll move that there. You know, so I've been trying. I just really don't know what I'm doing. So, yeah, the overall goal here is that we need to design a circuit that has a USB-C vertical mount that fits in right there, because that is where the Osmo Pocket charger is. That's what we're trying to do here. So, yeah. I think Tim thinks I'm trying to make my own charger circuit, which I am very much not trying to do. All we're trying to do is take that USB-C and turn it into wires. That's all I need to do. I need to use what's called a breakout. And yes, I can go online and actually buy USB-C breakouts. If we go to Amazon, we can look at a USB-C breakout, something like this. And this is kind of what I'm going for, where it's just like this, but for $6 a piece. I'm not doing that. Now, the only issue with this is that this is a female, and we're actually looking for a male. This is actually the connector that we can get. But if you guys see, there's really not a lot of... here, let me open this up. There is not a lot of stability here. And that is my biggest concern. If these things don't go in dead straight and they wiggle a little bit, you're going to lose these pins. All right. So, yeah, that's what we're trying to do here. So Tim is telling me, and so I've kind of already been working on this just so I can try to figure it out. But, you know, we're going to get rid of this. We're going to save it. But we're going to take a look at KiCad and try to figure things out here. Sorry, I've got Tim on Discord. We're talking back and forth, but there's nobody here anyways, so I guess it really doesn't matter ultimately. It's a bit of a bummer that we don't have anybody watching, but it is what it is. This is the life I live. Dang it, my phone's going off. Hold on. Does any of this matter? No, none of that matters. Yeah, no one is here, John, I know. I don't need to be reminded of that. Thanks, though. Alright, so we have KiCad here. We really just want to create... I'm just going to create a whole new project. I think that's just going to be easier. We'll create a brand new project. I'm going to I'm gonna put this in its own folder, which will just be in here. So we're gonna do USB-C breakout. It's basically what I'm trying to do is do a USB-C breakout. All right. So now that we have this, this is so weird. I don't know why it does this. Just put me right into the schematic editor right from the start. I don't want to go anywhere else. Put me to the schematic editor. I guess some people don't go straight to schematic editors. I don't know why. I don't make the rules. I just have to play by them. Alright, so now that we have this, I've done a few things ahead of time to try to, like, not hate myself for the next 2 hours. Even though I feel like we're gonna find ourselves there. I went to DJI and Mauser. We don't need this anymore. So I went to, it's not here. Okay, so we have the PCB library for Mauser, which uses some sort of library loader. I could not figure this out for the life of me. For the life of me, I could not figure out how to do this. I use their library loader and all of this. I don't know what it's looking for, where it's trying to put things, or why. So I've just abandoned it. It says, now click open ECAD model. Okay. Now what? Now what do I do? I clicked open, but there's no models, and I don't know where the ECAD models are. So we're not using that. Mauser, sorry, you're out. It's okay, Allison. YouTube doesn't always send notifications to people. That's common. Alright, so I ended up going to DigiKey because DigiKey actually has like a straight up, you load it in, it's so simple, I figured it out. KiCad library, it's through freaking GitHub, which is even so much better. So we're just gonna be doing that. Now, I'm told that I can also use Eagle. I'm assuming Eagle's very similar, and the nice thing about Eagle is you can utilize it inside of Fusion 360. So you do need a license for this. I'm using my education license because my paid license doesn't include Eagle. But my education license does, so we're using my education license for today. Unfortunately, I don't know the commands in here, and I'm slowly figuring them out here. So and oh, okay, well, Tim is telling me that fritzing, which is where I was going to do my design work through, you can actually do Gerber files. Now, it is paid, so it's $8. Fritzing is apparently like CAD for idiots, which is, or not CAD, but circuits for idiots, which is what I need. I need circuits for idiots. But I've kind of already committed to using KiCad, so... It is my understanding that you can put fritzing into KiCad as well. Justin, I don't know how to do it. Again, all of this comes down to a lack of knowledge on my part and a lack of very clear understanding on an industry level. I believe the class I took in college was called Volts for Dolts. I love that. You know, I should just retitle this to Volts for Dolts. But this is not, like, I can... And see, this is the hilarious thing. I can draw this circuit out perfectly. I know exactly the circuit that I want to make here, but I don't know how to make it in the program, which is the problem. Like, I know intrinsically it should be pretty simple. So let's go over that real quick. We're going to place a symbol, and we're going to search for USB-C. Now, hilariously, because I've already done this, it's got it up here. But this is what I was trying to find. And to filter this, I can just do Type C. Dang it. I forget that you can't click enter. Why? I don't know. Type C, and if you click enter, it instantly picks the first one on the list, so don't do that. We are looking for not logic flip-flops, not HDMI connectors, not battery management. We are looking for connectors. And in here, we're going to be looking for the actual connectors that we want. Now, the reason I had to load in DigiKey is because from what I can see, these are the ones that come stock with KiCad, all these USB-Cs, but they're all female. And I need a male connector. So, we're gonna get that. These are all HDMI. Where is it? It's not those. Hilariously, I don't see it when I search Type C. Type C? Dang it. Well, again, I am so used to hitting enter. This is going to forever frustrate me. Let me do USB-C and see what comes up. I think this is going to get me more. No. We don't need power protection. We're not doing any of that. We don't need HDMI connectors. These are all interfaces. We don't want that. We don't want battery management. No microchips. We're literally just looking for connectors. These are all silicon, which you can't buy anyway, so it doesn't matter. Why am I not finding the thing that I found last time? That is so ridiculous. These are all USB-A's, USB OTG. No. I'm looking for this. I know what it is, I'm just grabbing it. I just don't care at this point. I've already found it, so I know what it is. Now, the next thing I need to do, because this doesn't immediately tell me, is I need to go and I need to pull up the actual pinout for USB-C. Now, I'm going to have this on my other screen so that I can see it, but this is the pinout diagram that I'm using. Because, you know, if you guys can see it, I can't. Well, I only have two screens, and I can't show you both. So, yeah. So when we look at this, we see that A6, which is right here, A6 is Power Plus. Now, I learned that we can place global labels, and we can do here. And what I want to do is do V Plus. And this will enable us... Ooh, I need to... I think it's R for rotate. It is R for rotate. So, A6 is plus... Whoops. I need to do another one. V plus. I have another one there. And the reason that we're doing this... USB Type-C might be the operative search phrase for that. Well, let's find out. So that's... Yep, he's right. It is. It's USB Type-C. I don't this is the other problem of being in constant pain. You never remember things. Alright, we're going to do another flag here, because this is our V minus. Now, the traditional way to do this, and I need to bring in another component, and that component is, I just need to get a connector. So I need to get a header, I guess? Yeah, probably a header. I don't think we're going to use... We might use 2.54 JST. It's probably easier for us just to do that. So this shows us that this is vertical. We have vertical. These are SMD. So these are just straight up SMD mounts. SMD. So this is probably what we'll use. But the 2.54 variant, if I can find it. A 40 position. Perfect. Let's use that. Header 2.54 millimeter. That should probably give us a little bit better. I don't really want 12 position. And see, these are all vertical headers, so that's not what I'm looking for. Ah, damn it. I clicked enter again every single time. I need to get out of that habit. Really need to get out of that habit. Hilariously, it does not appear the KiCad comes with this, so I'm glad that I brought in that. We'll use... I don't want to use a vertical header. Really, I could just unpopulate it. So what I want to do is I just want to have holes. I just want to have pad holes. So let's see. Those are all vertical. So I'm looking here. We have vertical. We have SMD, but these are 1.27. Vertical 2 position. 40 position. RA. I don't know what RA means. Let's find out. It's going to open that on my other screen, so let me bring that over for you guys. So when you click it, it'll open up the actual diagram. So that is not what we want. And it's 2 millimeter anyways. Let me just search 2.54 and see what comes up. We don't want any of that. No amplifier. I really do just... I need connectors. Oh. Apparently just looking up a connector. Okay, so it's called rectangular connector header male pins. But I don't want male. Unfortunately, that's my only option. That's a shame. Let's see. This isn't what I was hoping for, but whatever. We'll just use this. All right. I was hoping for something else. Was that a Justice song? I have no clue. This is Orbit by Ellis, the song that's playing right now. Okay, so now that we have our pins, I need to bring back up my pinout diagram. Because traditionally... Oh, I need to rotate this. Because... Oh, no. Alright, so when we rotate, apparently I need to just have all of this selected. I want my shielding down. So we have V plus and V minus. Now, we can go here and easily label this V plus. Okay. Just like that. Or, we can grab our wire and we can go from here, here, just like that. That'll do the exact same thing. Now I'm going to put another label right there. So I'm going to do V minus. And if I do this accurately, it should allow me to do both, I think. I'm going to connect this to ground, because that's just shielding. And we have some other grounding wires, and it is all these wires here at the end. Now, I'm going to be crossing this wire, and you might say, well, Grant, that's gonna be a connection point. No. Connection points are the actual dots, from what I can tell. And, like, literally, I think this is what we need. Literally, I think this is all that I freaking need. Okay, just to give you guys an idea of how simple the circuit board is, I think this is literally all that I need. Because all that I'm trying to do is pull power. I need to be able to push power into a USB-C, and that's it. This is not a complicated circuit. I'm just an idiot. I'm not an idiot. I'm just uneducated in this, and unfortunately, a lot of the education stuff that I tried to find was not working. Like, could not figure it out. So let's see here. Oh my gosh, I hate the zooming feature in this too. Now we have to go, I think it's the labeling feature, not bitmap. We need to label. Labeling is the next thing that we do, and I forget where to do this from. Let's see. I think this is it. Hierarchical label. Nope, that's not it. Where is my labels? Oh, annotate. Okay. I think all I have to do is just click annotate. Okay, cool. We're done. We're annotated. Theoretically, we're basically done. I think. But I want to actually design this out in CAD. Because I think I'm going to have a better chance. So, let me pull some, God, I would love to do it with this, but I can't buy, I cannot get these assembled. So, USB-C male, nope. Man, we have, like, no USB-C male pieces. Like, we have USB-C cables, but I want a PCB. Nope, that's not gonna work. I need basically... Ooh, I wonder... Can we go to the ever-loving McMaster-Card and find it? Can you buy circuits from McMaster-Card? You should be able to. It's McMaster-Card. So Quilon is asking, what's the size you can work with? How big are you intending the connector to be in total? The total size that I've given it for the circuit board, I think, is 37 millimeters wide by, is it 37 square? Did I do 37 square? 37 by 34 millimeters. Although I'm pretty sure I did it 34 millimeters square, and then I gave myself room for wires. What I'm trying to do is I'm trying to find the CAD model for this, and I wonder... Let me go to DigiKey again, and let's see... Let me search for USB-C male. No. So I want to do USB-C. So I'm going to search USB-C. We don't want to convert. I'm gonna do my entire product index USB-C. Okay, yeah, it's gonna... Okay. I said we were gonna do this together. I didn't say it was gonna be easy. But I want a PCB. Oh, this is adapters. I don't want adapters. I want connectors. Card edge connectors. Wait a minute. Is there literally just one? Like, this is basic. You said photos. If photo is definitely available. Show me your data sheet. This is effectively what I'm trying to make. This is literally all that I'm trying to make. Right there. But I need it to be male, and all I need is power. That's all that I need. Literally all that I need. That is what I'm trying to make, and I just don't want to pay crazy Adafruit prices for it. That's what I'm trying to make. For those that are trying to figure out what the hell is he actually trying to do, that's what I'm trying to do. So let's see. We're in like sin where we need to be. We need USB Type-C. We need a plug, which I'm guessing is going to be the male. Right? Yes! Okay! Alright. That's a start. That's a start. So we can look at these and say, well, I can pull the data sheet and I can take a look at it. This is... Yeah, this would work. We've got some extra strength there. I want to find ones that are reasonably strong. They're $1.69 a piece, which kind of sucks. So we'll leave this window open. He's just going to get more tabs, ladies and gentlemen. That's what we're going to do. Let me search for price and see what we can get kind of at the cheapest. And, of course, you clicked the wrong thing, you ding-dong. So we can see the cheapest that they have stock of is going to be this one. Although I guess I can order these. I want to see the data sheet. These look like they're pretty sturdy. Sturdiness matters a lot to me because these could be under some stress and strain. Did the same song? No. Okay. I'm going crazy. So we can see a lot of things about the data sheet. I think we're just going to pull... Not that one. You can go away. I don't need you anymore. I prefer it to have solder tabs like this. I think that's going to be the strongest that we can do. Because remember, we're going to be giving it a vertical force. 1,000 times at one time coming. Yeah. Just, look, don't at me about all my tabs, alright? Don't at me about my tabs. I know your real name, sir. Alright, let's see what else we need to get here. I think this will be good. Can I get a CAD model for this?
You can't control me.
Ah! Haha! Easy EDA CAD models! Haha! Haha!
Open your eyes.
I would be I'm getting yelled at in the comments for my very poor tab management and all of that. There's no 3D model. Damn it, Bobby. I need the 3D model. What's Ultra Librarian? PCB CAD library. Okay. This could be a bad move. USB-C male connector. I would have better organization if I wasn't in such constant pain. I got another shot this past Friday, and it has made sitting effectively unbearably uncomfortable for me. So I am not comfortable sitting right now. And of course, I can't stand, because that's pretty bad too. So I'm just uncomfortable in general. So I apologize if I'm not my normal chipper self. If you guys can see it in some of the videos, I apologize because there's nothing I can do about it. I just had a shot in my back and it's really messed me up. It's unfortunate, but this is the way it works sometimes. We've got everything labeled. I want to... Oh, I have to assign footprints? This should be fine, because it knows what this is. I really just want to design this thing in CAD. I really just want to design this thing. I just wish I could design all the traces in CAD and then just export it and say, make me PCB, please. But I can't. So, here we are. Yeah, I'm sorry. If you guys keep seeing me moving, it's because I'm trying to find comfort. And I can't. It is... I'm averaging an hour of sleep a day right now. I'm in bed for like 6 or 7 hours, but I'm averaging an hour of sleep. Of restful sleep, I guess we should say. My average sleep has been cut in half since this last shot. What the heck's going on? Alright, I need to get back into here. I also don't like how all the stuff is in separate windows. Do it in tabs, please. 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 Alright, so we've got everything. Cool. Yeah. Okay. Alright, is fritzing really that good? Hi, Lauren. Is fritzing, if fritzing is that good, I will hide my screen and I will buy it right now. Or I'll just, I'm just gonna buy it. Forget it. I've spent more money on dumber things in my life. I'm gonna, yeah. We're gonna get fritzing right now. Here, I'll turn the music up, and I'll turn my volume down. Fritzing is not free. To download it, it's €8. Unless I'm an idiot, which I very much could be. Every time. Oh. Okay, so you can download fritzing for free, but it's kind of a mean way to do it. Let me show you. I wonder, what's a business? I don't know what a business card means, but... Yeah, so... It says, I already paid, which will let you download it. So I assume that's the way to get it for free. Turn the music back down. I assume that's the way to get it for free. Is that gonna work? It totally works. Okay. Alright. Alright. Fine. Fine. Let me get this thing finished installed, and we're gonna use it, because, yeah, I, just... Some things I just can't, man. Sometimes I just can't. Why am I on BRB? Just go to Big Grant. That's fine. Only for me. I'm gonna put it in my E drive because that's where I store all of my memories. Give me just a second. So fritzing is not technically free, but it's free enough. Free enough. If it's this good, I will go back and I will pay them. Yeah, I know. I turned the music up when I was doing things on my keyboard. That's the next thing we're doing, Justin. We need to do that max mix thing so I can just quickly and easily deal with different volume knobs and sliders and crap, because that's what I want to do. Alright, here's fritzing. Let's do a schematic. Oh my god, yes! This is what I'm looking for! This stuff where it's so simple an idiot can do it. This is what I live for. Alright, let's look for USB-C. What are you? You're micro. Let's see. Oh, you give me nothing. I wonder. These are all USB-Bs. Nope, fritzing doesn't have what I need. How do I load libraries into fritzing? Let's find out. Because that's the next thing I need to do. Go away. I don't know if I want to... I mean, we'll use the Adafruit fritzing library, but... Hello? Oh, okay, it's gonna download it that way. Okay. Alright, let's do this real quick. Oh, you're still downloading. Good lord. File. Open. Downloads. Nope, that's not where you do it. Can I just... Okay, cool. Alright, the issue that we now deal with is the parts that I want aren't in fritzing. What I need to do is not complicated. It's really not you know what? I'm gonna do it in CAD real quick. I'm gonna show you guys that what I'm trying to do is not complicated at all. Alright, I'm gonna grab a rectangle there, another one there, because we're gonna need 2 boards. I'm gonna finish that sketch, turn on our sketches, turn off that sketch. Let's do, I don't know, 30. Okay. And then all I need to do is I need to put my USB header on here. I need to have solder pads connecting it, and we're done. Like, literally, that's all that I need to have. So. Ah! If anyone knows how to do this, please reach out to me, like DM me on Twitter or something, because I'll have you on this call, because I can't do this. I cannot do this. I can't do it. So, I don't know what to do from here, and it is not clear. This is why there needs to be a program for people that don't understand this stuff. Because I don't know what I'm doing here. And there is no tutorial on how to do this without watching multiple videos or even taking classes. And if the average person like me wants to do something like this, I shouldn't have to pay an electrical engineer. I would pay one of my electrical engineers, but they're all busy right now. I think I'm done. Sure, we're gonna save all, and we're gonna X out of that. Let's do PCB layout editor. Okay, I'll enable acceleration. Sure. How mad is my computer right now that it needs acceleration? It's fine. Where's the board? Hello? Why is this so honestly, why is this so unintuitive? Seriously. Like, why is this black and red? I don't know if you guys can see it, but there's red lettering down here. Why is this black and red? Why is that so hard to see? Circuits should not be this complicated at all. Are you going somewhere? Where are you going? The cat's leaving. Even the cat's mad. Because, like, this should not be this difficult. And... oh my god. Like, okay, cool. Fritzing, but I can't do anything with it because it doesn't have the things that I need, and there's no easy way to add libraries to it. So I'm being told it's likely because the standards were set since the dawn of time. Obviously, no. I'm so pissed off right now. I'm so mad because like this is bullshit. It's bullshit. It should not be this difficult for a layman to design a damn circuit board. Like, if I can do this in CAD, why is it this difficult to do? Why should I need an engineering degree to know how to do this? Why is this so unbelievably unintuitive? Like, I get that I'm just complaining, but I'm sorry, I'm trying to actually finish a project here, and I'm gonna be forced to go the route that I didn't want to go, which is literally just using 90-degree angled connectors, which is no fun, but it's the easy route to go. It is the absolute easy route to go. Like, where's my board that I just designed? Where are all of my parts? They're not here. And why is the background black? I love dark mode, but red on black doesn't work. It doesn't work at all. So I don't get it. I do not understand why this has to be so complicated. Like, where's my board that I just designed? This. Where is this? In there. Where's the board? I just designed it. Why is it not here? God, this is so frustrating. There. So it doesn't auto-update. You're forced to... oh my god. I just... man, I can't. I friggin' can't right now. I can't. I just friggin' can't. I friggin' can't. That is the most frustrating thing. So much frustration. Alright, now we need our wires. It's gonna come from... nope, not there. Golly. How tiny are these pins? Okay. Like, this is literally all that I need here, guys. Like, seriously, this is it. All you gotta do is you just gotta connect all your connectors. You just gotta connect all your wires together where they belong. Okay, and by the way, the red that you're seeing... Okay. Oh, Jesus. Come on. Insane. The red, I believe, means it's on the bottom of the board. I'm honestly not certain. Let me go to the front side. Yeah, okay. So red is top side. What cross are you talking about, Justin? I am... Alright, I gotta go over here. There's another wire that I need to make. No, I'm gonna short this thing out. What isn't needed? What? Okay, I'm told that this cross isn't needed. I don't see why that matters, but okay. I'm gonna... How do I delete? It's not the delete key, because that would be useful! I can't, man. It is the delete key. Okay, sure. No, it wants those connected. You can see it wants those to be connected because on the main... Damn it. If we go back to... If we go back to here, it wants those to be connected because they're all ground. Okay, so B12, B1, A12, and A1 are all ground. Now, I'm going to come in here and I'm going to delete some of these wires. And I'm going to do the labels. I'm going to label this V minus and just be done with it. Because that should be how it works. But these all need to be connected because they're a solid, it's a solid tap ground. So I need them to be connected. I need this to be accurate. All right. I don't understand why it doesn't just open here. Why when I click this that it has to open in a brand new window rather than opening right here? There's all this empty white space. Why don't you just open there? I don't friggin' know, man. Alright, so we need to get the negative for this side. Which is this. Oh, shit. I'm trying to go to the negative side, which means I want B7. I don't want A5. And I don't want B8 either. What the hell? B7 should be minus, yes. This whole zooming feature is absolutely atrocious. How do you people that build circuits not just hate yourselves constantly? Because honestly, that is really bad. Like, really bad. Yeah, there was no need for that to go that way. Let's go to the bottom. I don't want to go that way. Are you really going to make me go all the way around like that? Why can't I just go across? Oh, right. Yeah, because vias are a thing. You can't have traces cross each other. Of course you can't. Idiot. Oh, man. That's my board! My whole damn board, but it's not the board. I need to be able to design the board in CAD too. But I need to get the 3D models for what I need to design, but I can't find those because they don't exist. This is the problem that we're dealing with. The things that I need don't exist. And I don't have the technical know-how or ability to do it. Which is the further problem that upsets me. Justin, I need the 3D models because I need to design the boards inside of View. Damn it. I can't easily explain this to people, and this is why we have this problem. No, the 3D models are not just for pretty. I need those 3D models to make sure that things actually fit. I don't know where I need to place this thing on a PCB, and even further, I need to have two PCBs. I need to have PCBs at angles. And I don't know how to do that outside of doing it in CAD, and I barely know how to do it in CAD. This should not be this complicated. At all. I shouldn't have to look at 6 different programs. Easy EDA is absolutely no better, and you have to log in for it. So, get out of here. Fritzing, I can't get the right part libraries that I need, so that doesn't help me either. And I'm sorry that I'm getting really frustrated here, but I am in a non-trivial amount of pain, and I am not allowed to have pain medicine, so I'm just not in a great mood right now. Because I denied opioids once, because I didn't want to have opioids at the hospital, and because of that, I've been denied pain management. It's so much fun. I love it. I love it. I love having herniated discs. What the hell is the answer for this? Because, like, I need a board that has a USB-C header on it. Male. So I can plug it into the bottom of these freaking cameras. Okay. And then I need that to go to pads that then need to fit into another PCB that those pads solder to for both support in some areas, and that in other areas are for actually electrical connection, right? The solder is both mechanical and electrical, separate, but mechanical and electrical. And then that goes to my pin headers, but I want just holes in the board, not that. So, I don't friggin' know, man. This should not be this difficult. I'm considering just ending the stream here, guys. I'm sorry. I'm so frustrated that I can't think straight. Because this should not be this difficult, and it basically makes custom circuits completely impossible for somebody like me to obtain. Can you use rectangular cubes to max dimensions? I have no clue what that means, unfortunately. I'm sorry. I can design all of this. Oh, use rectangular cubes as the placeholders. I know, like, I can pull a USB-C male, but I can't get it with the pin headers that I need where I need it. That's what I'm dealing with. I mean... Right. Okay, so Quilon is saying that I should just draw it as a box. And yeah, I could do that. I'm just... Oh, Jesus, I'm in so much pain right now. No, that's not it. That's my personal window. I'm gonna go back here. Unless, if we go to JLC, JLC will show us specifically what they can and can't use. So that's female. I need male. Let's see. Do we have a male? We do. It goes to 27. Okay. No, it literally goes to freaking 1! JLC recommends to use Easy EDA, but it's the exact same problem that we're dealing with. We're dealing with the fact that some of the stuff doesn't exist, and yet I know that it does. I know this stuff exists, it's just not accessible to people like me. And that's frustrating. JLC recommends to use Easy EDA, and I even have Easy EDA, because I tried it. It's the same problem. We run into this exact same issue of, alright, we'll create a new project, cool. The problem here, and I can just go to my USB-C project, is that, again, I don't have the footprints for anything. So if we go to, like, the library, and we do, Type-C, USB-C, no, USB, no. Let's go for a library. JLC Viper GTSR is asking, did you look at maybe what JLC uses for their software to make PCB layouts? It's Easy EDA. That's what they recommend, but it's just as complicated. It's just as complicated. I'm bringing on an electrical engineer. I don't give a shit. I'm asking our guy, Alan, to come on because I don't know what the hell I'm doing and I'm frustrated. So I'm going to pay an electrical engineer to come on and help me because that's the only... This should not be this difficult. There's... Either I'm just a complete and utter moron, which I've never put past me. Or this is just not possible, which is also completely fair if it's not possible. Alright, Alan's gonna come on stream. We're just gonna do this instead. I am just... Oh, I'm so mad. I'm so mad here. Alright, I'm gonna bring one of our engineers on hand. We're gonna bring on Alan of Pyroball PCBs. And, I'm gonna have to turn off the music for that, so... Oh well, but you're gonna have someone that actually knows what the hell they're doing, so that's a plus. So I'm waiting for him to get set up, and then we're gonna talk about this. We're gonna talk about this! Of course, and now I also have to turn Discord noises back on. All right, Alan's getting set up, and then he's gonna come and give me a hand because, yeah, this shouldn't be this difficult at all. And I'm betting I'm missing something stupid. But yeah, this doesn't work. Also, since I'm pretty sure I emailed you back, do you still need those parts printed, Viper GTSR? Because I never heard back as to whether or not you needed them printed. Let me know if you do. I'll throw them on a printer today, but I never heard back, so I'm like, I don't know if he needs parts printed still. So yeah, all right. But yeah, this is Easy EDA. Easy EDA is a little bit easier because it shows you stuff right here, which I do like, but it doesn't solve my problem of not having everything that I need available. Okay, here's Alan. Oh, it's not gonna let me have my camera on. Give me just a second. This is perfect. My music stopped. So that's perfect. Exactly what I was going for. You there, buddy? Alan?
Yeah.
Hey, how you doing?
All right.
I am gonna bring you on the live here. Give me just a second. Oh, you know what? I'll just share my screen with you. Let me share my screen. Okay, you still there with me?
Yep, I gotcha.
All right. I'm gonna give me just a second. I'm gonna add you into the stream so people can see your face. Unless you don't want people to see your face.
It's the stuff behind me. I'd rather they not see.
Okay, no problem. They don't have to see a damn thing. All right. So here's what we're dealing with. And I believe the people on stream can hear you. They should be able to. I don't know if you've been following it or not. I assume you haven't been, but I am building a charging can for DJI Osmo Pockets. These things. Okay, so these are the cameras that we use on our YouTube channel. And
making one of those big old like charging docks for doing a bunch at once, right?
Totally. That's exactly what I'm doing. Okay. The thing is, these charge by USB-C. Okay. So I've got my ammo box designed out, and it's literally, I just copied a 30 cal ammo can that I have here. This is the bottom, this is the top, and then there's even a blank base that goes underneath it to keep all the boards secure. But what I'm trying to do is design this custom circuit board. Now, I recognize that I could easily just go get right angle USB connectors, use USB cables, and I'm done. But that's not fun. And
well, also it's not a secure. You know, it's a lot actually easier to get the machine to build the circuit for you than it is for you to do the wiring. So
that's where I'm at.
Yeah. Really, I'm all for eliminating as many human errors as possible.
And so I'm over here trying to learn KiCad, and you know, Alan, I have just come to the conclusion that electrical engineers are masochists because this is truly one of the most unintuitive programs I've ever worked on in my life. I found,
to be honest, like last time I worked with KiCad was back in 2015.
You use Eagle.
So yes.
And as far as I can tell, they're basically the same thing.
Yeah, I mean, like there's some differences in terms of like what are the background stuff too, but the biggest differences are obviously going to be the user interface and then hotkeys and things like that. And
what they both do that frustrates me beyond reason is they open everything in new freaking windows. I don't need more windows. Tabs. I want tabs.
Yeah.
Look at my Chrome. I want tabs.
Well, you want tabs with group organization. That's what you want.
So I found that vertical USB-C male, there's like one that exists, and it's got zero stability. Right? If you're off by even, you know, half a thou, it's gonna snap off the PCB and you're done. So I've relegated myself to saying, okay, we need to use a mortise and tenon style design where we have a PCB down here, another one that gets soldered in like this, and then they have
if you're showing me something, I can't see it. I can only see your screen at the moment.
Oh, that's right. You can't see me.
Yeah, you're currently just a big blue screen with a 3D Musketeers logo in the middle.
Oh, give me just a second. I can do this. Where is... Ha! Now you can see me and the stream. So now I can stop streaming to you. Okay, so I'm trying to do time for MS Paint. Yep, done. MS Paint. Do I have MS Paint? I do have Paint. All right.
Cool.
See, Paint is intuitive enough that I understand it. See. Okay. All right. This is hold on. I need to properly title this. I'm gonna title it 3DM EDA because this is what I'm calling it now. This is 3DM EDA. So here's what I need.
Cool.
I need USB. USB. Okay. I need wires to come down from it, and then I need another board that is here, and then those wires connect to this, and then I have either pin headers or some sort of is everything backwards for you?
I can see it.
Is it backwards for you though?
It's not backwards for me.
Okay, cool. And then I need to be able to then have wires. So the reason that we have to do it this way, and I guess I can also do it in Fusion, but the reason that we have to do this is because I can't find any vertical mount USB-C connectors that I can get assembled. So this is like the USB-C connector that I would use if I could, but I can't get these on assembly. Nobody assembles them.
Okay.
And they're also like...
they're using that. I know that style of connector. We actually use those in the ones at work. That specific thing where it's got the two little holes on the side, the hatch, and the this whole little, like, the row of pins to either side and the tabs going through. We use those at work for our video routers, actually.
Because these are great because they provide a lot of that vertical stability that something such as... This is literally the only thing that JLC has. There is no stability on that whatsoever. Like,
I disagree. You've actually got two tabs to either right and left there. Those little flanges with the holes in them. What you're supposed to do with those is to put some very, very large ground pads to either side of the PCB. Okay. Those little tabs go into basically another mortise sort of situation, and you flood it with solder so that it just sort of it bonds it to the board.
Okay, so that does have some security then.
It does. Not much, not as much as some other things, but it does have some. So the trick with this one is going to be building the footprint such that it'll work with those flanges. In such a way
the little 90s on there.
At either corner. Of
okay,
that
with the little
unit.
holes in them, the flanges. Okay.
Exactly.
So for something like this, I should do my PCB footprinter symbol.
What I would do is actually pull that footprint and all that stuff. I would edit it so that those two pads, the one on either the north and south ends, would make those actual holes, through holes.
Oh, these here,
and,
the 17s?
Precisely, yes. So I would actually expand those outward about double what they are now to
turn them into holes. Yeah. So how do I download this and use it?
That's not something that I can help you with EasyEDA. However, what you might be able to do
I'm not
is
using EasyEDA. This is JLC. They want you to use EasyEDA.
Of course. So they've got their whole symbol and footprint already done for you. So what you need to do is we need to either find an Eagle formatted part for this, which might be possible, or we have to build one. First thing you want to do is to go back to where you're just looking at and hit the download on that data sheet for the JLC part.
Okay. There's our data sheet.
So here here's our data sheet, and there's our footprint mechanical drawing in the center down at the bottom.
Oh, here.
To the right of that. Yeah, there you go. There. So if you zoom in on that, that's what we'd be using to build the footprint within Eagle, and then we'd go and attach all the pins to their designated nets and things like that.
That sucks.
We would make a library for it. Yeah, it's kind of tedious, but like that's how you have to do it if there's no available library available anywhere.
So, could I
So
potentially find this from somebody else?
absolutely. So the first place I like to look is Snap EDA.
Snap EDA?
Yeah, just open it. Yeah, snapeda.com, I think.
Yes, I'm adding another tab for all of you haters out there. I'm adding another tab.
To be fair, like I have an entire tab group just for this.
So I should just grab their part number, right? Their manufacturer part number.
Yeah. All of the, yeah, was that the manufacturer partner? But I couldn't tell.
Yeah. Nope.
Yeah, darn. Okay,
Didn't
so
match
take
anything.
take off the last couple of alleles of that. Try taking things off until you come across something. See, we got some things that were starting to come through. Okay, scrolly until you find something that's similar. And if you don't find something that's similar, we might have to go back to board.
This is
Yep.
a detector
So
switch, but it
it says that. I
definitely
think it's a connect. Well, it's probably a connector with a detector switch built into it. My guess. But it's also it looks like a micro. No, it says C.
yeah,
I suppose.
Snap EDA is quite slow, but my computer's probably also quite mad. Oh yeah, yep,
Right.
yeah, it's mad. Okay,
Okay. Well, like, okay, so it looks
that's
like the JLC provided one might not work. The
do I?
What I would do at this point?
I'm
Sorry?
trying to see if this is male or female.
That's female.
That's female. Okay.
That's female. That's definitely female. Okay, so JLC may not be the best source for those parts.
Right.
The other option that we have, as you mentioned last night, I think, was that we can do a 90-degree mounted male, and then we can split this PCB and do the mortise and pinion thing.
So hilariously, this is the result that I get when all I'm looking for is Type C and male. This is the only male Type C that JLC PCB has for their assembly service.
That's strange, though. I think it's mislabeled. That doesn't look like a male to me.
I'm pretty
That's a
sure it
female.
is.
That's a female, I think. Oh, okay. If you look at the top view, top right-hand corner, see that it's got pins on the inside. No, left corner. Sorry, my bad.
Oh, here.
You'll see that it's got those 6 pins.
Am I just a moron and I
that.
actually need female because inside of this is
That's a female. Oh, because gendering gets kind of screwy.
I need this. Oh, hold on. I'm gonna grab a USB-C cable. I need this end. I need this piece. This is what I need.
You can buy those on Amazon actually. Okay, so back in the day, when the Switch first came out and we were doing all that hacking with it, and there was this thing that you could do where you could buy a feather, an Adafruit feather board, and buy a USB micro to USB-C adapter, and basically strip the casing off of it. And inside of those adapters, there's the USB-C micro or the USB micro connector attached by five big old solder pads to this PCB that has the C
And you could just
connector on it.
you could just pull it off.
Precisely, yeah. And then you could stick that whole assembly onto the feather board and use it to do the injection process on the switches. There you go, right there.
Yes.
Okay, that's it.
Yeah.
Yeah.
This is what I need.
So what you are going to have trouble with on this is that doesn't have any of the structural elements that we would really want for a mount.
So that's why I'm thinking that we look at something that's sideways like this, and we do a board that's at a 90-degree angle.
Exactly.
That to me solves all the problems that we have.
Yeah, that would. And like that's something that I see a lot of manufacturers do actually these days for very, very small compact sort of things like miniature cameras and whatnot. What I'll actually see them do is take one PCB, split it up into 3 different pieces, and then they sort of curl it back on itself with these solder pads so that it's in the shape of like a square tube almost.
Right.
It's very common for some of those the smaller devices you get from China these days, actually.
So interesting. We've got some other things going on here because now when I look at JLC, all of these are not the right connector. They literally. Well, wait a minute.
You just glossed over one that looked like it might be, and that looks female to me. That's the one we were going to use on one of our other projects, I think.
It's always the tough part with this
sure.
because they don't show you the side that I care about. Yeah, okay.
That's a female.
Yeah, it's female. It's got the dingus on the inside. Yeah, literally on.
Hey! Oh, hang on. That looks like. No. That's
Nope. Female.
Yep. Let me get you images, man.
Well,
Chrome extension
and
lets
so
you...
the issue that I'm dealing with here is that I don't know how to design this, right? The issue that we come into is that I'm not an electrical engineer, which I know, crazy. You never knew that. You never knew I wasn't an electrical
never would have
engineer. Guessed. You, however, are.
Yes.
Is the reason this sucks so much, is that because there is like a standard that's been around for years and that's just the way that it's been?
Are you talking about like how things are designed?
Yeah.
And like the workflow process? Yeah, that is largely an artifact of the previous generation of CAD.
Well, I hate
basically. So everybody that got into this back in the day started out on AutoCAD basically. So it's had that lovely 2000s 99 kind of feel to its user interface. Everybody got used to it. And because that ended up being the industry standard for so long, many of the programs that were developed afterward kind of followed it.
Right.
Once you've gotten past the learning curve, it's not that bad. It's just a matter of like learning the user interface and the hotkeys involved and the workflows, which that takes a little while. I mean, I could probably spin somebody up on that in a couple of weeks.
Yeah, I tried to learn this in a week, and all that I ended up doing was wanting to hurt people.
Doing it by yourself, that's going to happen. It would take you something on the order of a few months to a year, I would think, if you were just doing it by yourself. And that's just to get to be able to do like some of the basic PCB stuff, sending something out for design and whatnot. If I was going to go into like all the base principles and
right.
How to actually do the math for stuff, that would take quite a lot longer.
Right. Well, and that's what I'm trying to figure out is how I accomplish this. And if I need to use Eagle, I use Eagle. If I need to use KiCad, I use KiCad.
It depends on which you feel like learning more, because you have an Eagle license because you've got Fusion 360.
Right.
So you're good there.
I believe even hobbyists can get the Eagle license, though. I don't.
They can, yes.
Okay.
They can get the Eagle license. There are limitations to what you can do with the free license on Fusion 360. There's oodles of videos and complaints about this from when they changed it over. You guys can look it up if you want. But the advantages are obviously having things that we can collaborate on the cloud with, things like that. The parts libraries are far more prolific in the Eagle, and the ability to make those parts libraries. I actually don't really know how that workflow goes in KiCad as well, so I can't really say whether it's easier or not. But I found that since they've changed over from the older Eagle style to Fusion 360 and that part libraries management, adding new parts and libraries and things like that has gotten way easier.
Okay, so then let's do it in Eagle. So I guess the first thing I need to do is I need to bring in. I need to update. I need to open a library.
But why don't we do this in Fusion, and then I can do some of this along with you.
So I'm stupid and don't know how to do this inside of Fusion.
Well, that's really easy then. So go up to that little file thing for
here.
Yep, and do new electronics design.
Oh shit! Okay.
And now
All right, I thought it would
then-
be somewhere else.
It's really easy.
Okay.
We're also gonna do one more thing, which is to go and do another new and then do an electronics parts library.
Okay. All right.
So
So do I even need to have Eagle open or no?
you know,
Huh?
you do it all in Fusion now. Eagle has now been merged into Fusion. You can do it all within Fusion these days.
Oh, hell yes. I'm not going to save shit. I'm closing you out. Goodbye, Mr. Bond. Look at this. I'm getting organized. It's in tabs. Alex, if someone said Eagle inside a Fusion uses tabs, I wouldn't have even touched KiCad. Oh my gosh. This is so much easier.
There are windows that still pop up, I will say.
Ah, dang it.
So you're not entirely free. There are tabs. It does make things a little bit better, but you're not entirely free from it. Okay, so I think the first thing we should do is go and add a new schematic, which is that far left button under the common.
Yep. Okay.
So if you want to get a little bit of real estate back, go ahead and close the extension thing there, and you don't really need the design manager or the inspector right now. There's two.
Really, the big reason that I leave it open is because my image for the stream covers, and I don't know if it's going to cover anything that's going to matter. But
so the other thing that you can get rid of here are the inspector and the design manager. If you look just below the touch bar, there you go. Perfect. Yeah, those little double arrows things.
And the inspector,
you will,
seriously. Okay.
Oh, you don't need them right now. You just minimize the inspector side there instead of the whole bar. All the way in the far right. There you go.
Okay.
Now you have room to see if you.
Yeah. I got. There's room for activities here. I like this. I like
exactly.
This.
So the first thing you have to do when you're setting up a schematic is add a part. Now that part add button is to your right about 4 spaces. Is under library next to the one that says move. There you go. Add part. The first thing I like to put down is a frame, just to makes it easier to see the whole thing. Under the search bar, what I would type in is A3. Just do a star A3 star. That was an asterisk. It's hard to see. Yeah. There. Is that an asterisk at the front, or is that a quote?
It's an asterisk. Star A3 star.
Oh, maybe you don't have it. Go ahead and clear that search out and go ahead and click on the Open Library Manager. Alright. So what this is going to do is it's going to give you an option to download a bunch of community-supported libraries from.
It
Eagle.
says done, and there are no libraries.
It's because we haven't put anything in the design yet.
I got to go to available, don't I?
Precisely. Now go ahead and search in there. We're going to look for frames.
Looking for what?
Frames.
I missed it again.
Frames. Frame. Yeah. There you go. That's the one.
Okay. Download that.
Go ahead and use.
Use.
Go ahead and close that window again, and then go back to the search in that last window and type in star A3 star.
Well, I found the frames.
A3. I like doing the A3L location.
Okay.
And then hit OK. There you go. Now scroll out until you find that little X and stick it on the X.
Like straight up, right on top of it, just like that?
There. As close as you can. That's fine. Yeah.
Okay.
Now hit escape. Escape again.
Okay.
Go. Now you have your first part, which is just a frame so that you can know where to put stuff when you're doing your schematic. So that's the simplest part of doing this, which is just adding a part to your schematic. When you end up adding
somebody
parts
hand me an electrical engineering degree, I'm done.
Seriously, you just start with the basic shit first.
Yeah.
So the easiest thing to do is to get something referential for you to look at, so that you know what that you're actually looking at a document, not just an empty space of bullshit.
Right.
Okay. So
now we're gonna grab a part though, right?
Exactly. So we're using a USB connector here for part of it, but what else we need is like the other board pieces. We probably need some ESD protection diodes, things like that.
No, literally, this is just power. Nothing else. It's so.
Okay.
All this is, it's going to be a big breakout charge board, and you're going to plug in either a 5-volt power supply, like a regulated 5-volt power supply to it, or you're going to plug it into a battery bank, and you're done. That's it.
Okay. So there's a connector that a lot of people like using, that little the 6 millimeter DC jack.
I was going to use
Let's see.
XT30s. However,
Okay.
I am open to putting on that the protection circuitry in case, let's say, the regulated 5-volt output for some reason is 5.7 or 6.5 until you load it, right? Where it's a constant.
If these batteries just take a 5 volt straight in and they have their own like charging management circuitry built in, then you don't need that.
I don't know. They charge via USB, so.
Okay, then yes, that would be the case.
Is
So
it better for us just to put it? I think the only issue that we deal with is power loss, right? Because so Justin is saying diodes wouldn't be bad, and yeah, I totally agree.
Yeah.
But we're gonna have some loss over those diodes, won't we?
You're gonna have at most like a 0.2 to 0.7 volt loss, and that's not much. Like your losses in terms of your gains there are pretty minimal.
The protection that you get from a diode is better than not having it, right?
Precisely, yeah.
Remember,
it's just
ladies and gentlemen, always use protection.
Always.
Okay.
Something else that we could look at is you're finding the connectors that most people use already.
Yeah.
That was a female. If you keep going down, that last one might be a male. I'm not sure. Nope.
That's
Never mind.
mini.
See, that's an A male, but it's the wrong one.
Now,
okay, so we'll have to go and find a part.
Why is HDMI under USB?
That's a great question. Somebody else's library. I didn't maintain it. It's not my fault.
Okay, so they don't have what we're looking for, actually.
In that particular library that comes baked into Fusion 360, we can add our own. So there's a couple of ways we can go about that. One is that we can go through that library manager again and search for something. That is the easier way to do things if you can find something right away. It's harder because it's harder to find what libraries have what you're after. Exactly. So you can't really search what's inside them. So my usual go-to on this is to find a part that I can find on DigiKey or wherever it is that I'm going to be buying it from.
Right.
Then I go back to SnapEDA or somewhere else that has an EDA library that I can import. Failing that, I make it myself.
Okay.
If you want, we can try and find a library and I can show you how to do that, or I can actually go into how to build a part if you want.
Let's try to find the library first. I think that's because that's more realistic, right?
Mm-hmm. So I'm assuming that you're going to be assembling these yourself, right?
No, I'm gonna have the PCB assembled. Well, I'm gonna do the 90 degree myself, but the population is gonna be done all on its own.
Even if it was like a through hole part, something like that.
I don't think we're gonna be doing any through hole, but if it is through hole, I can do that all day.
I've seen some USB-Cs that are through hole. They're small, but they're through hole.
I don't want to bother doing SMD work right now because I don't have my SMD station set up. So if it's through hole, I can do it. But my plan was to go to like JLC or PCB ways and have them do the bulk of the assembly, and then I would probably end up doing the 90 degree myself.
Okay, so that case makes that means that we're kind of restricted to the parts libraries that they offer.
Yes.
Have you given her a trazodone yet today?
Pardon?
Have you given her a trazodone yet today?
Okay, so yeah, then we need to look through those part libraries, find what we have available, and if that's the only okay, so yeah, we got to go through those parts. Let's pick one out.
So the issue with JLC was as soon as we go to mail, there's only that one option.
Ignore the mail from. Oh, that's right. Shit.
And PCB way, which is kind of the other
It's
one that
gonna
people
be
were
way
recommending.
more expensive.
Huh?
Your setup costs on that are going to be a minimum of $1,000.
Wait, what? Really?
Yes.
$1,000 for a?
Yeah, for doing assembly, if you don't have okay, I'm not. I've never actually done PCB way, so I can't say that for sure. But whenever I've done any kind of small batch assembly that wasn't done from a house that has that whole system already set up, it always costs a certain amount to get the tooling set up and then you pay per unit basically.
I think
So
these guys
tooling
are
setups
they're PCBWay is a competitor to JLC.
Okay.
So I would guess
So
their
they have
pricing is going to
turnkey-
be reasonably close. But I mean, look, barring not being able to get the USB-C on the board, which it does not appear that we can do, all hand solder it. I don't want to, but I can.
It's just if it was any other type of part that wasn't so hard to find, I would say let's just go with the assembly service only. Just kind of dubious about what they have available and how to design around that properly.
I mean,
Because
hey,
like yeah,
I don't
we
care.
were looking at it's. I think the one we saw that we saw on GLC
This one.
isn't an actual male. It's not a male, I don't think.
This one. No, it definitely is. It's empty on the inside.
Okay, it's really hard to see. It's kind of pixelated on my side.
Sorry. Yeah, it's empty on the inside.
That's okay.
It's a male.
Maybe you could link me, and I can look at it more closely.
Yeah, this is definitely a male. Now, I'm worried that it's only half an amp, because I want to be able to charge these a little bit faster than that, but kind of is what it is.
Seconds, work just ping me or something.
You're fine. I can mute you if needed.
That's alright, just typing.
Is like USB-C one of those things that's just gone to the to the silicon shortage?
I don't think so. It's just that this particular type of part isn't commonly used. Most of the time, when you're building a product, you're accepting a cable input, not creating a cable output. So it's just it's a very, very unusual part to find.
I mean, look, we could do that, but then I would need like very short male-to-male adapters, right? But like, so how are USB-C cables made then? Where are they getting their components from?
Well, USB-C cables is a whole different beast than sticking something on a PCB.
Oh, that's true. They can just use these for cables. These would be totally fine for cables.
I don't know what they actually use in most cases. Okay, so cabling wise, most of the time, what's under the hood of those things is like what we saw on Amazon, where you have those little tiny PCBs that are sort of straight back from the connector, and they have the pads at the end of them. But like the high quality cables are a little bit more sophisticated than that. But most cheap ones are basically just those PCBs with a little bit of solder and wire going between them, and then they encase them. So like those are not 90-degree connectors. Those are flat. You notice they're being stuck on the board edge, or they're flat against it. So 99% of the cables and connectors that are made that are male are all going to be 90-degree.
So what I'm trying to do is just so freaking specific that it's just not something that people do?
Pretty much.
So instead I should just be doing USB-C 90-degree. And just get, not any of those. But like...
Oh, hang on.
What?
The one on the far right there. You could literally like... like stick a bunch of cables on it.
And see, that's
you can cut that casing away, and probably get that. Or like, there's other like little adapters that are like this. You could use, but.
I mean, there definitely are. My goal though was to do a custom PCB, but this may not be the right move. I didn't think that a male vertical mounted custom PCB would be a thing and be difficult to find.
Yeah. It's just a weird use case is the thing. If you can find, look under that under JLC, see if we can find one that's just flat against the board. 'Cause we can make the PCB work with that.
Yeah, no, literally, when you search USB-C and then male, the only one
I think
you get.
the tagging, like I said, I think that tagging is wrong. We might just need to look instead of
physically
relying on the tags. Yeah. Because I think, like I said, I think that tag is incorrect because it looked like a female to me.
Yeah, problem is they don't always give you the images, so you end up having to open up a ton of different tabs on data sheets to find it.
If on the other hand you go and get the Chrome extension images, you can just hover over it.
Like that?
Yeah, it looks a little bit different on my end. But,
Oh, the problem is sometimes you can't see it. So like I can't tell. I'm fairly certain. Like, well, no, that's definitely female because of the way that it's mounted. Definitely female. See, I figure
let's see.
if it has that little pin on it like that, that's gonna be female. Because a male
Not
won't plug into
necessarily.
that. A male, you would need more distance out than that.
Right.
If I'm
So
making sense.
yeah, I see what you're saying now. Yeah.
Yeah.
Those all look too short. The male connectors are about twice that long.
Right. Right.
Hang on,
That's the male
see if I
connector.
can-
That's the one that we had.
That's not. It's not a male connector. It's too short.
This is definitely a male connector. It's just SMD male connector.
Let me see. Let me see if I can find it. Hang on. Yeah, I'm
I
looking
sent
it up
you the
on
data
GLC
sheet.
on my side here. Okay. If I go and search
So okay,
male use.
I'm at the
Wait,
point.
I found more.
What?
I found a lot of more than you did. I'm not sure why. Hang on. So yeah, I'm on lcsc.com, products USB connectors _369.html. And I filtered for USB Type-C and male only. I have 4 results.
Yeah.
5, actually. And there's some that would work. Ooh, this one would work really well.
LCSC. It's not
Yes,
Lewis
LCSC.
Clark State College, I assume, right?
lcsc.com is the sister site to JLC.
Okay. So so JLC may not have stock then, basically.
Possibly, but LCSC does, and that's who they build through. So, yes, connectors, USB connectors.
So I'm gonna go to connectors.
USB is all the way at the bottom there.
USB.
And then again, filter for male and USB.
Type
There you
C. Male.
go. Male.
Apply.
And then apply.
I get 5. How did you get 4?
I got 5.
Okay.
Misquoted. That very bottom one is pretty promising to me. XKB connectivity.
Yeah.
That's a through hole, but like that'll give you a lot more strength with the connection. Oh, it's not a through hole. That's the kind that it's a board edge. My bad. Is it?
I mean, I can do any of them. I don't particularly care.
Let me look at the data sheet on it. Hang on. No, this is one I would do personally.
This one here.
Yep, that's a board edge one, but that's fine. We'll just do the mortise and pinion dealy bop with it.
How do you add strength to it, though?
I will show you.
Now, stupid question. Why wouldn't I just use something like this? That's
We are going to be doing these. We're going to be making a custom one of those. So that connector that we just looked at is that connector, and they just added their own PCB to it.
What
However,
about that
those
black
don't.
piece of plastic, though?
That's a different one. The other one was It was the same kind.
Okay.
There's one you were looking at just a minute ago. That one. That's the same connector. That
Yeah,
one.
this one here.
So you see how they've got the PCB sort of up in the connector's business in the
Yeah.
back? That's partly how they're creating some of that strength. And what we're going to be doing is, instead of it being a flat board edge at the back end where it will connect to the other PCB, it's going to have sort of like mortise and pinion thing where you have like notches cut out, and it'll slot into the other board. And
Oh,
there'll be
they don't have
solder
any in
holes.
stock, so probably means we're out of luck.
Well, I mean, we can do the design. They'll get back in stock eventually. And these connectors are one of those standard footprints, as far as I know.
Right.
We can still design around it, even if you don't have it right this second.
Why is it the one that we like is not in stock?
Because that's the one everybody likes, I'm sure. Either way, it's something we can definitely do.
So I can pull the data sheet, but all we get is the Easy EDA model. Now I have Easy EDA. Can I download the Easy EDA model? Oh, there's not an Easy EDA model here.
All right, kill that. Let's try and snap EDA on it. The XKB connectivity thing is more likely to have something, I think, than the
Snap
random
EDA.
Yes, snap EDA. And stick that part number in it that we were just looking at. Yeah,
This one.
That one I think we're more likely to find something. Stick the yep.
Start
Now you
cutting
get
numbers.
Okay.
Oh, I got something. No.
No. Shit. Okay, so it's probably under a different name than on the actual sheet. So my guess is that they've abstracted it to something else.
I'll try to copy the
It's gonna be out.
LCSC part number and see if that comes up, but I doubt it will.
I doubt it will. Yeah.
Nope.
Shoot. Well, I mean, I can make you a part number for that in Eagle if you like.
No.
Okay.
No. That's one that's not fair to you, but
Let's see what we've got.
Well, if the data sheet gives us the numbers, I can do that stuff too. I think maybe.
Sure. I mean, I can walk you through it, at least getting you started. Happy to do so. The footprint on this isn't too complicated, thankfully.
Is that it?
So we'll probably end up adding a bit more like what we call silk screening to outline the
Shouldn't
part
we be
for when you're
breaking
doing
them in
something.
half too? Because let me see something here. Yeah, this is. If you did this, you would short out the USB-C, would you not?
What do you mean?
Because if
It's on either side of it. If you look on that center image, the one the 2.4 by 03,
yeah,
scroll down a little bit, you'll notice that the PCB is going in between those two sets of pins. So it's on either side of the board.
right.
The board is going right up the middle.
Is this holes in a board or is this pads?
Those are SMD. Those are surface mount pads.
Okay, they're
on
pads.
both
Yeah,
sides
so
of the board.
if I was to solder something to this, I'd be shorting the front and back side of this.
On either side.
Okay, you have this on
Not
both
roll.
sides, you mean?
Exactly. Yeah,
Okay,
There's
okay.
one set of pins on either side of it. That's how USB-C works because you have the reversible business going on. So
I got you.
when we do this footprint, we're going to have to basically tie in the pads for each side together programmatically.
That's gonna
so
suck,
that the system. It's not that bad, really. It's more complicated for the USB stuff, but you have to do the same thing for any device that you build anyway. You have to assign the pins to where they go.
Why is this so complicated?
In this case, because electronics are complicated.
I want Lego for circuit design, damn it! And Fritzing is not it. I was told Fritzing
No.
is it. Fritzing is not it.
No, so there is a point you can get to that you can actually do stuff like that, but it requires a lot of setup, and it requires like somebody having done the design for those design blocks. If they don't exist, you have to make them yourself.
Right.
That's the problem.
Okay.
So like it's not complicated if somebody's already done the abstraction, and a lot of cases they have been done. This is a weird edge case that you have to do yourself.
Right. Okay. So I need to copy these into Eagle, or into Fusion, I guess. Copy it into Fusion, design it out here. So how do I do that in Fusion?
So first thing we're going to do is go back over to your parts library. And that's going to be that tab at the top that says Untitled at the moment.
Oh, here. Okay.
First thing we're going to do is make a footprint. So in the those buttons at the very top under Document,
Yep.
all the way to the top. There you go. Create new footprint. We're going to name it something. I would go with the part number.
Oh, okay.
Well, actually no. Go just say USB-C.
It's fine. I can.
And we can. There's a reason I'm saying to call it USB-C at the part level here. Yeah.
That's what I'm doing.
There you go. Okay, great. Excellent. Okay. And now.
Oh, okay.
What we're going to be.
SMD.
Yeah, so we're good.
So I need an SMD pad.
So here's what we're going to be doing from here. We're going to be adding pins first. And and then we'll be naming them and then assigning them to different net classes. So the first thing we're going to do is there's a pin, an SMD pin add button right up next to the move button at the top bar. Right. A little bit more to the right. Other right. You see the move button that's got the 4 arrows?
Am I? Oh, yeah.
There you
okay.
go. There you go.
Add pad.
Right. So.
Okay, now I got to figure out the size of the pads. Okay. Okay.
So
I can do that.
Here's the thing. You want to add the pads first because you have to sort of modify them all at once if you want to do this not tedious way. Ignore that for now. We're just placing pads.
Okay.
We need to place enough pads. Yeah, you can change the size now if you want. Oh, that's new. Delete and type it out. Actually, before you do that, cancel that. You see that little grid button right underneath the part that says to automate? Hit that. And this is your grid settings. So right now it's set to mils. I hate fucking mils because nobody does it.
Millimeters.
Precisely. Hit OK. And now when you go to hit your add SMD pad, you'll notice that the measurements are now in millimeters. All right.
Okay, so that's 0603.
So let me actually note out the size of the pads for you. I can do it because I have it up for me.
Okay.
We've got let's see. Our pads are it's 12. Oh, wait, is that in mils? Those guys. Okay, 2 seconds. I need to read part of the data sheet.
Of course, it's in friggin' mils.
It's not mils. 12 by 1.2. Okay, yeah, it is. There's 12 of them, not 12 millimeters. All right, so it's 1.2 millimeters tall. Let's see, the width on those is 0.7. For 2 of them, and then the rest of them are 0.3. Okay. So, all right, go ahead and get your add pad, 1.2 to 0.7. Actually, switch it around so that it's 0.7 by 1.2.
Yep. I know you have to get going soon too. Damn it.
I'm actually okay at the moment. Do 2 pads at that size, one on either side. You can just place them wherever for now. We're gonna adjust the positions later.
And then we need a bunch of 1.2 that are how much?
But leave the 1.2. It's 0.3. And you need 1, 2, 3, 4, 5. It's 12 total. 1, 2, 3. We'll change all those positions later.
Okay.
Is that 12?
That is 12.
Okay, cool. So now, okay. So if you take a peek back at the data sheet, I'll show you.
Without multi-monitor,
exactly
this would be terrible.
It is. That's why I have 3 monitors set up whenever I'm doing this shit. Anyway, so you'll see that we've got these measurements, noting exactly how far apart things are from each other. There's a point of origin usually, which is that center line at the very in the very middle of that. It's kind of dotted.
Yep.
That one. And then down here at the very base, you have another line that's sort of solid to left to right. That's our origin spot. So all the measurements are generally taken either as a midpoint from that, or as that is the origin. And it's adding or subtracting from there. So in order to find out the positions for each of those pins, we kind of have to do a little math. We're going to be taking.
Well, they're 0.5 spacing on center. Right here.
Right, exactly. But you have to remember we're referencing everything from that origin point. So its position is the center of the pad relative to that origin. So we need to find out mathematically.
It should be 0.25, should it not?
0.25 of what? There's 3 different measurements.
I'm sorry?
Well, there's three different measurements we need to make for each of these to know where to put each of these pads. Which is its x-axis location, its y-axis location, and the midpoint of those of the pad itself. So we're going to be doing. If you go, I'll keep the data sheet up on my screen and call out numbers for you. But go ahead and switch back over to Fusion 360. And what we're first going to position is that big pad on the left. Go ahead and right-click on it. You can also change it on the right hand bar if you rather
right
not
here?
do the pro. Yeah, I forgot you can do that. If you want more visual space, you can close that sidebar and then right click and go to properties. But if you don't want to have the pop up window, you can just do it on the side here.
Yeah, no, this is fine.
Okay, so what I would do is first name the pad GND for ground because that's all it is.
Right, right.
And what this will do is when we end up adding this pad to a design, Fusion 360 will automatically pick that pad up as a ground plane and add it to that net,
Bingo.
which is great. So now we're gonna go and because this pad's gonna be okay, so here's the tricky thing about doing these damn designs. They give you the measurements to the far edge of the pad, not to the centers in a lot of cases. This one, we're lucky they did give us the measurements to the center, so we're actually going to be. I'd have to do less math, thankfully. The center up to that is. Let me get a calculator out. Crap. If you want to pull up the data sheet, I can walk you through what I'm doing.
Sure. I have to
from
switch
the very
gears
bottom-
in a few minutes. We have a YouTube premiere, but I'm gonna come right back to this
okay.
when we're done with that premiere.
Okay, so on the very bottom right of that drawing, you see the 2 by 1.4.
Yeah,
That's
the height.
the bottom. That's
no.
the height of the bottom edge. That's the height of the bottom edge of the pad. So I have to add another 0.6 to that to reach the center of the pad because they're 1.2 millimeters tall. So our actual vertical height on all of these pads is 0.2 or is 2 millimeters. We can go back to Fusion 360 now.
I don't think it is. I think actually it's 1.4 for the side ones, and then 1.5 for the middle ones. Height.
Correct. Notice they're all the same height, all 1.2 millimeters. The difference is the horizontal size. All of them are the same vertical height. We're only adjusting the vertical height at the moment.
Okay.
And the vertical height is we have to measure to the center for where we're placing it. So the measurements they give us are to the bottom edge, so we have to add half of the width or half of the height of the pad
Right.
for the center position. So go back over to the Fusion 360. I'm going to select all of those pads actually. Now, you go let go. And you should be able to go and on the right hand side is the vertical, I believe. That's the one that's got the number in it. The position that's your X and that's your Y on the right.
Okay.
And the right should be 2. Yep. So they've all been positioned correctly vertically now. It's easy. Now the vertical or the horizontal positioning we have to do individually. So go ahead and click on the left one. And that one is thankfully very easy to figure out. It's 7.2 divided by 2. You can do calculations within Fusion 360 here.
You can.
It's really nice.
I did it. 7.2 divided by 2. It didn't.
You need to do a /2.
I did a slash.
Oh, it doesn't. Oh, fuck. Oh, I thought they would have allowed that. Damn it.
Nope.
All right.
Nope.
Well,
so it's what 3.6.
Yeah, 3.6.
Okay.
Yeah, worth a shot. Wait, that is okay. You need to add a negative to the front of that since it's to the left of our origin. There you go. Now we just go to the next one. And that is going to be since it's the pin pitch on those is slightly different for the first one. It looks like 5.5 divided by 2, so that's going to be 2.75. We have 2.75 right.
It doesn't like negative. There it goes. Okay, negative 275,
Yeah.
and then the pin pitch is.
And then there's .3, so negative 3.
Negative 3.05.
Well, you're adding to it, not subtracting. So it's a negative number, so it has to go down.
Okay, so 2.45.
There you go. So the size is a little.
Those pins are touching.
They're overlapping. They are touching. That's strange. What the heck is going on here? It's a point. No, the pitch is 0.5. My bad.
Okay.
The size of the pads is 0.3. The pitch is 0.5.
There we go. Okay, so.
Then so basically we just do the same thing. We iterate through all those pins until we. That one's fine. You just do the next one. Oh, I see what you're doing. You're getting the measurement.
Okay, so this now needs to be Negative 2.35 minus 0.5, so negative 1.85. Why are you not taking the negative? Wait,
Not
what?
Sure. That's off a little bit. 1.95, my bad.
Yeah.
Remember, it's point.
No. What?
Wait a minute. Wait, 0.35. It's 0.5. Yeah, 0.5 pitch.
Oh, because
Something's off
this should have been 2.5. This should have been 2.5.
My bad. My bad.
2.5. Then now this is 7.5. That looks right.
There we go.
Okay.
That's looking better.
We have to do a
Okay,
YouTube premiere real quick, so I gotta go do that.
Okay, we can come back to this.
Okay. Well, you know, I bet I can leave the stream running. Hold on. And I'm gonna do the YouTube premiere right here on stream. Screw it. What the hell?
Right.
Let's do it. Cause
Right.
yeah.
Well, if you're gonna do
that,
it, I'm gonna pop off to another meeting here.
Yeah.
Just ping me when you're done.
Okay. See ya.
See you later.
Screw it. Let's do the premiere live. I don't care. Let's have some fun.
Hey everybody, if you have a goal you're trying to accomplish, check out Udemy. Right now, Udemy is having a...
Oh, it's so loud. Every time, YouTube. Ha! I can control you, though. I'm gonna literally do my own YouTube premiere live. Because I can. Yeah, if you guys aren't over, go over to our YouTube premiere and watch that. Elegoo is dropping the bomb on me, baby. I know this guy. He's kind of weird looking. For their newest planetary exploration, the Jupiter. Let's talk about it. Elegoo is coming out with the Jupiter, their largest resin printer to date, and they're doing it via Kickstarter to some mixed responses by people. But I don't want to get into that too soon. Let's actually dive into the meat and potatoes of this thing, because this printer is kind of crazy. It is a 6K monochrome LCD. You know what? I'm gonna go BRB here. I'll be on the YouTube premiere. 278 but I'm gonna turn off audio. You guys have to go watch that YouTube premiere. Go watch that YouTube premiere. All right. We're finishing this thing out, and we're going to go back live again. Just waiting for this to finish up. I didn't want to have it, like, playing on both. That just felt weird. Like, listening to myself on loop again. Okay. That is the premiere done. Now I just gotta wait for Alan. Let me get him back on a call here. Do-do-do, do-do-do. Because Discord. Hey, dude. Sorry. I didn't expect that we were gonna end up running right into the YouTube premiere, but here we are. But alright, so I just need to start adding, what, 0.5 millimeter or whatever to all of this. So,
Yeah.
175, this now goes to negative 1.25. No, negative. Jeez. It doesn't take the
keyboard
negative.
might be having some wonkiness there.
Huh?
I wonder if your keyboard might be having some wonkiness there.
No, not at all. I'm hitting the negative arrow, it doesn't work. But if I do 0.75, and now I do the negative, it works totally fine. So, just, I don't know, man. I don't know. Let me use here. Yeah, no, it doesn't work. So if you do 0.25, come over, negative, done. So interesting.
I can't tell if that's a UI paper cut thing or if it's a systems. I'll try it on my end at some point and find out. It's a bit of bug or something. So
that's fine.
After we've done
now we're on the right side of the problem.
Yeah, basically. So
you know,
once we've done this bit, we kind of have a decision to make, which is do we make this part so that we can use only one side, or do we make it so that it has to use both sides no matter what?
I don't know.
Well, the reason I ask is because if we make it the way that the manufacturer specified, we have to add a second set of these pins on the bottom.
Why on the bottom?
Because they're mirrored. That's how this footprint works. The USB-C cables have the exact same pins on both sides of the cable. In this case, both sides of the board.
Give me just a second. I got to figure out the pitch between.
The last one, just duplicate the other one. You have the pin on the far left. Just make it
okay. So
negative.
do 3.6, and that'll get it.
Yeah.
Done. I figured it would be on either side of the component. Is that not accurate?
It is on either side of the PCB. The component itself has two sets of pins.
Oh, this thing is gonna be so the edge of the PCB. The component's gonna like sit on the edge of the PCB.
Yes, the PCB slides into this thing.
What?
How you get a decent amount of strength out of it.
Okay. I mean, what the hell? We might as well add them on both sides, right?
This is like the tricky thing, though, is you have to then make another set of pins. And
please tell me I can just copy paste it, right?
I hope so. I'm not sure. I've never actually tried.
So I
it
go top, go to bottom.
Yeah, basically, and then.
I think it's there.
Work?
I think it's there, dude.
I only see one.
Yeah, no,
you're
that's bottom.
On top. That's on the bottom, but what about the ones on the top now? You only changed one pin. So if you go ahead and hit that layer at the top there, you see where it says top right next to the measurement. After that a little bit. You see where it's red right underneath the trash icon. It says one top.
Oh yeah, okay.
now go ahead and hit bottom. Okay, so yeah, you still only have one set of pins here. You have one pin on top. The rest of them are all the bottom. So we actually do need to add, unfortunately.
Oh, that's a pain in the ass. So how did that one work?
Because you clicked on one of them and then switched it to. See, if you select all of them and then switch that, then you don't have to do it individually.
Oh, wait a minute.
Okay.
I have a thought then. So I want these to all be...
Use your magic mouse cursor to select them all first.
I did. I'm going to turn them all to bottom. I have an idea.
Right.
It might not work. We're going to select them all. Control C, Control V. I'm going to copy them. Hold on.
Right.
Hold on.
Yep.
Okay.
Yep.
I'm going to grab them all. I'm going to click. I'm going to go to top. And then I'm going to move them on top of the other ones.
Before you do that, yeah. All right. Move it back up first so you can see both rows first. We have to rename them.
Oh,
Right,
do we?
No. Yes, we do. Unfortunately.
Okay, but this is the right way to do it, right? Like, am I like reasonably smart for this?
Yes, you are. Good job.
Yay! Somebody bring me a cookie! There's nobody else here. Damn cat's not gonna bring me anything.
This is something that we didn't used to be able to do back in like Eagle like 9.1 or something like that. You couldn't do that, which is really annoying. But now it looks like they've gotten rid of that paper cut. So great. Anyway, so now we go ahead and like click on each of those pins. We're gonna change the name of them. I think click on one of the pins. Let me see if it shows up in the right. Yep. There. Okay. So yeah,
This one isn't renamed though. This is GND2, right?
So yeah, basically for each of these pins have to have a unique name. So all the ones that are ground, you're gonna have to iterate up the numbers, obviously.
Oh, okay. So okay, we have ground 1. It didn't hold it. What?
Didn't hold what?
Ground 1.
Yeah.
This pin. Click the damn pin. Okay.
Type it and hit enter.
Oh, that might be it. So, okay, and this is ground 3. Oh man, I got a client saying they're gonna bring me a treat. I'm gonna hold you to that.
All right.
He knows where I live, so he actually could. Don't drive all the way over here to bring me. I actually can't get up. I'm gonna have to crawl out of my chair because I can't feel my legs. But that's, you know, that's another problem for another day. That's future Grant's problem. Present Grant is stuck in the chair, so he's gonna keep working until this shit's done, or until 3:30, because I definitely haven't. I have to do an interview at 3:30. So
Cool. Okay, so
I don't want to be doing this that long, anyways.
Okay, so now we've got to do the other pins. So the top boards from left to right are going to be A1 through A12.
Okay.
And then the bottom are going to be reverse order because they're on the bottom. B1 through B12.
Yep. This is a real pain in the ass.
This is why people like finding other people that have already done it and like importing libraries because it's tedious.
Okay, so the only reason that we have to do this is because this doesn't exist otherwise.
Precisely. The reason that we're naming each of these pins, we don't necessarily need to name each of these pins. It just makes it easier for us to do the connections of the parts later. So you can let it just have the pins that like the auto naming, but that drives me absolutely batshit when I'm trying to actually connect pins and stuff. So.
I mean, that's fair.
You'll see exactly what I mean in just a few minutes when we go over that side of it.
If we can maintain the USB-C naming standard, that's probably better for us. So I'm gonna leave my caps lock on. B1. I was holding the shift key. It was annoying. B2.
If I remember correctly, this thing does caps automatically anyway.
Does it?
For pin. I think it does for pins.
Oh yeah, it
and
totally
for
does.
nets.
Totally does.
There's a few things that does caps only for.
This whole thing will be done. And then I get to go and edit the live stream because it got way better when Alan got on. I screwed something up. Shit.
Oh, you moved it back. It's cool. B4, B5.
Okay.
Go.
Nope, B5. Yeah, I should have just planned this ahead of time and had you on here. In my defense, I was trying to. Our schedules just never met in a position that made sense for either of us.
Well, this week has been absolutely nuts with my pup going in for surgery, so I don't blame you.
That's fair. Well, at least you didn't have Justin's problem, but we're not going to talk about that because YouTube doesn't like when you talk about those things.
Right. Okay.
I got a epidural shot on Friday, and dude, it has been so bad. It's been so bad. I can't sit comfortably anymore. And
Geez. I thought that was supposed to make you more comfortable.
Well, so it changes things. And this one, this one made stuff pretty rough. Pretty freaking rough. All right, so we got everything named.
Now we got to move that row of pins back down.
Yep. So I got to select them all, move them down.
Okay, so now we have a choice. We can we should add at least the net name, or the part number and part name on it. So we're gonna go to that layer pull down menu you saw earlier where you can do top and bottom.
Give me just a second. Okay.
And what you want to look for, I guess you go back to top. Yeah, okay, that's fine. Go ahead and hit the text window, or there's an A on that. There you go.
Yep.
And what we're gonna put in the enter text thing is right hand caret name. All caps.
Right. All
no,
caps.
like the greater than symbol. Right hand caret.
Oh. Okay. I'm like right hand character name. I'm like that's a lot of shit.
Right-hand
carrots. Right.
Like carrot, like the green thing you eat. Anyway, all caps name. What this is this is a placeholder that Fusion 360 will then replace with whatever the part name you give it on the schematic.
Oh, okay, that's right. Because we can do fun silk screening stuff on this, can't we?
Exactly. We can add the logos and all that stuff.
Goes to find
so,
Dick Butt online.
Yeah, we can definitely do that if you want.
And you can't change the font family.
You can. There's font right there. It's proportional first.
Idiot.
So you can do custom if you want to do that, but I prefer in most cases to do vector.
I want to use
it works better. I do what now?
Ossifont.
Okay, cool.
I don't know. It's just the font that
I would put the ratio at 11%. Just makes it easier to read.
Okay.
And
just hit OK.
Hit OK. No, put your cursor over the field of pins area.
Oh.
Now, place it down somewhere.
Okay.
Go ahead and escape, and hit escape again. Now you should have the ability to right-click on the name. There's a little X just to the lower left of where the caret is. You can't really see it on my screen, but yeah.
No, I can't do that.
Try a wider selection than what you did, a wider window. Okay, I hit Control Z then. I'm not sure why it did that.
I'm guessing it's because of the text that I did.
I don't know. It shouldn't be.
I'm going to go to vector. Oh, hey! Ossifont is the one I can choose for vector. Or
it might just be that way because you already selected it and it's doing something. Anyway, I'm just trying name again. It should have the ability to do a. There should be a tops a different layer that you're able to put it in though is the thing, and I'm not seeing that at the moment. So click back up at the top.
I screwed it up. Give me a second.
The layer pull down.
Vector.
And remember, you don't hit anything. Just
click.
Before you do that, click on the layers again. Okay, there's only routes. What the hell happened to the silk screens? There it is. T place. Sorry, team names. Excuse me. My bad.
Click there as well.
Before you do that, go back to the layer and do team names. Placement is a different thing. That's the one. Go.
Click right on top.
I would hit the right click button. Go, and now you can stick it next to it if you want. It's a right click to rotate.
That is why would I just use R or something to rotate? All right, so right there is fine.
Everybody uses it. Yeah. And then although you should probably get rid of the other name because that's actually on copper.
I don't know
Hit
how to
escape
do that.
to exit. Escape. Or
I'm gonna cancel.
you still have the name thing on. You might need to hit escape in again.
Oh shit.
You just hit Control Z.
Yeah, I hit Control Z too many times. I get it. All right, we're gonna go T names. We're gonna do the little alligator name thing.
No S. No S.
No, name. K.
Place wherever you feel like.
All right, there. Done.
Now you can cancel out of it.
Do I hit OK or do I hit cancel?
Doesn't matter. Hit cancel will actually remove it from there. Okay, great. Now, if you want, we can also do a little bit of silkscreen lines to indicate where the connector will be on the board itself and where the board edge is. Let me see. Let me see. I'm finding exactly how tall that bit is really quick. There's one part of this drawing that is missing.
See, I can't select this name again. I can't reselect it.
Yeah, I'm not sure why that's the case.
I'm gonna remove it for
yeah,
now.
I know. I can stop. I know why. Hit Control Z again. So show you exactly why. On the right-hand side, there's a selection filter menu. Now you only have pad selected. If you do all of those, like click one and hit Control A, or Shift and then click to the bottom one. You have to make sure all the types are enabled. Now you only have attributes.
Okay.
So,
I have to Control A this.
Yeah, you have to select all of those. Might need to do Shift and click. There you go.
Okay.
Perfect. Now you should be able to do it.
Aha!
See the little X next to it? Or the little cross there is the origin point.
Stupid like a fox! That's right! That's right!
But this is one of those UI paper cuts I was hoping we'd run into because it gets everybody.
Why does that suck so much?
It's not like this is something that's actually very useful in a lot of circumstances. Just people accidentally click on that and then lock them out of being able to select anything and then get frustrated and quit.
Brother, I would have been here for longer than I care to admit. Trying to figure... I would have been yelling. I would have been pissed. Because I didn't know
This right here...
Man!
This is one of those things that learning on your own is hard to figure out. That's why, like, having somebody to help you along can really speed up that process.
Thanks, Alan. Everybody needs an Alan. And by the way, if you have a 3D printer and you are looking to make it better, you can go check out Alan at pyroballpcbs.com, where he makes the awesome Pyro Piezo bed leveling systems. Level your beds like never before. I made up the slogan.
Just a disclaimer, it is not for newies because I'm lazy and haven't actually finished making all the cable harnesses yet, so you guys kind of have to make your own. Sorry. Also, I've run out of the 3-pin ones, so I have to buy more.
We're gonna be upgrading a 3D printer with one of your mounts on it. I think it's gonna be. Yeah. Part of me wants to just do it as an individual, but like I have more electronic knowledge than the average person does. I've just never, like, I've breadboarded stuff. I've built Tesla coils from scratch. I can solder quite well. I even have SMD rework equipment. But I never have built my own PCB. And I've always wanted to do it. I've just never had a reason to do it other than right freaking now. And I feel like now I'm just going to do it more often just so I can.
Might as well. I mean, you can make yourself fancy coasters or...
I want PCB rulers.
Door hangers.
I want the rulers.
Rulers are more expensive because you have to make them long, and GLC has that 100mm limit before they start charging you a lot more. So
I think PCBWay has like, I know DigiKey does, where you can just order the PCB rulers.
Park has a bunch of them. There's a bunch of them on Amazon too, by the way. The one I really wanted though was the one NVIDIA gave out back in 2014.
It'd be fun if I made one, because it would just be full of memes. It would have like, you know, pad things. I don't know. I've always also wanted to do PCB business cards with.
I did that myself, yeah.
Like, and that would be cool. I just think it gets expensive very quickly. But
actually, like, so when I did my last batch, I paid about $40 for 200 of them.
That's not bad.
So one of the tricks that you can do is because the business cards are a certain size form factor that you can fit two of them within a 100 by 100 millimeter area.
Oh, easily,
And
yeah.
if you can if you can fit under 100 by 100 millimeters, then you get those PCBs for extra cheap from JLC. So what I do is I panelize them, is what it's calling, where you take a PCB and you duplicate it on the same space, and then you send them off to be manufactured like that, so you get
And then you
as
drill
many
all
as you
those
can fit
little
within the
holes in
space.
it so they can snap apart, right?
Yeah, they call those mouse bites. So yeah, you drill holes in between them, and then you just snap them apart. Exactly. Um, anyway, so back on the design we're doing here. Do you want to set up those board edge lines, or do you just want to leave it as it is?
No, I want to do board edge lines so bad because that will help. I've been trying to figure out how the frig to do this because, like, that's what I want to do. I want board edge lines. Because, like,
So
to me, it's like, we don't have any, like, I'm not dimensioning anything. Like, the first thing you do in CAD is you draw a box and you dimension it. But the first thing in PCB is, like, you do all of that last. Ish.
Yeah. Okay.
So...
But I just found something out, though.
Huh.
I was looking at the wrong measurement when we were looking at the height of those pins.
Don't do this to me.
Well, luckily for you, it's going to be very easy to fix because all you got to do is highlight all of them. We only have to change the vertical size. So it's SMD size. What we're going to do... Oh, shit. That's right. We have the two on the edges. All right. So reselect. Only do the ones in the middle.
Okay.
Perfect. Now, that's going to be 1.4 millimeters.
Okay.
So I misread part of that data sheet, so apologies on that one. Yeah, but
Are
other
the
than that,
ones on
everything
the
else
end
is spot on.
Any different?
Oh, see, what? Yes, they are. Those ones are also 1.4, so you can just change them back to that.
I mean, if the pads were a little short, it's probably not the end of the world.
It's not. It's really not. It just makes it harder to solder. Usually, what you want to have is a little bit of extra length on those SMD pads, so that you can get the solder.
Right, it'll wick up a little bit easier.
Right. Exactly. You can heat the pad without having to touch the pin itself.
And you don't have so little pad, you just melt the pad off the board.
Too. Yeah.
By the way, I'm
More
going to
surface
order
area
something
means it's
like
better.
I need 8 of these boards. I'm probably going to order 20. But
If you want, I can show you how to panelize them so you can literally order 2 and get 20.
yes, we're gonna get there. What I do want to do as well, I've had some time to think about it, and my dad has always told me to use protection, so I would like to make sure that we put either some diodes or something in there. So my assumption here is I might end up doing something. Let's say I screw up the solder for whatever reason, and I now I guess I can get a USB-C tester to verify that everything is copacetic. But I want to have some diodes in there if we can, just some basic protection stuff.
Easy peasy. Yeah, we'll just do some Schottky diodes. If you want, we can even add some LED indicators so that you can tell when it's plugged in. When you plug it in, and it'll light up so that you know that it's got a good connection. That kind of thing.
Alan. Don't
That's
threaten
$2.
me with a good time. You say I can put blinking lights? I'm putting blinking lights. Let's friggin' go.
All that takes is an LED and a resistor. That's not hard. So anyway,
I know. But can I do RGB?
So at this point, let's go ahead and do those. That's more complicated.
Damn it!
But so for the board edge line,
Yeah.
it looks like, from what I can tell, there.
Line under
See
create.
if I can get a better. I'm trying to find out is if that board is supposed to extend further into the casing than where the pins are ending.
Why don't we
just
make
trying
the
to-
pins extra long, and worst comes to worst, I just come through the Dremel and cut it all off.
Oh, that's a good idea then. Okay, so
I don't want to,
might as well.
but I guess if it extends too far,
Your connector will just be sort of sticking out a little bit more from the PCB itself.
it won't have as much connection to the. My thought was that we end up actually cutting a little mortise out of it, and the thing slides on, and that way it also has lateral stability from the board next to it.
You will be having that as well, yes. So
Okay.
there's going to be both of that happening on the connector side that we're designing right now, as well as the board edge PCB where you're going to be soldering those two boards together.
Okay, so
We'll
let's
see that
make
in
these
just a
extra
moment.
long. Do we want to just go straight to
Let's-
2 millimeters and be done with it?
Actually, what we should do, shouldn't do that. We should first set the board outline for this.
Yeah.
And we're going to make a second part with a longer outline that we can swap out and under the same library, the same part and all that stuff. That way we can switch between them fairly easily.
And you know
So
what? Honestly,
first things first.
I'll just order both because it's not going to cost much. There's basically no parts going on this. And quite frankly, for how few parts we're putting on, it would probably be better for us to look at like some sort of low voltage dropout or a low drop diode that's through hole, and I just do all the soldering here and not even pay for assembly. Yeah, because if they're not going to be able to put the connector on,
Yeah.
then that's really the only thing that I need. Everything else I can do myself. And you know what?
This one, it looks like this one's through LCSC, which does the JLC PCB does work with their parts library. So,
well,
I
these ones
think
aren't
that
particularly the ones that we want. Of course, aren't the one. They're not in stock.
No, but the ones that I'm looking at, the one that we're designing for around right now is from LCSC, so that you can get it assembled through JLC. That's why we chose this one.
Okay.
We found that other one on LCSC.com. This one, yeah.
Yes, but this is the one that has no stock.
Oh, that's right. That's right. But like, you can buy those separate. Yeah, fuck. Okay, yeah, I forgot. Everything is out of fucking stock these days. Anyway,
Right? Right?
Literally, like 90% of what I'm doing at work right now is finding replacements for silicon we can't get anymore.
I mean,
Anyway,
would it be smart for us to look at using just this?
because that's the same device. We're making that little PCB that's going in it.
It's a stupid question. Why don't we just use this with the PCB?
Because that PCB doesn't have the strength extras that we're going to be adding.
Ah. And I'm not going to desolder from this. I don't have that kind of time.
Precisely. Well, there's no point. It's the same connector. It's just using their PCB instead. Anyway.
So I know, like, through...
Okay, so I'm looking at that one that you were just looking at. It looks like that PCB edge is literally just like maybe 2.2 millimeters above the end of those pins. So we'll just extend the pins down a little bit more and put that line above them.
Real quick,
So,
if I search this, will this tell me if I can find it through somebody else?
probably.
Oh, hey, there it is in
EDA.
Easy EDA. Oh, but that's Easy EDA. We don't want Easy EDA. I'm looking to see if I can buy
Easy
it.
ADA is also JLC PCB as far as I'm aware.
Right, yes. I'm looking to see if I can go to, like, DigiKey and buy it through DigiKey.
Yeah, I'm pretty good at finding these.
Not through DigiKey.
Oh. Yeah. Anyway, that's sort of irrelevant for the task at hand. So we can find them, I'm sure.
I mean, it's kind of relevant, is it not?
Only to a certain extent. Like, we have to find something that we can put a design around so you can get a PCB going. And like,
Okay, that's fair. All right.
that is, as far as I'm aware, that's a pretty standard footprint. Looks very similar to a lot of the ones I've seen. So
Okay.
I'm sure we can find one that'll work with it. Anyway,
And then we
so
just
go
gotta
ahead
modify our spacing to fit it, right?
Precisely, yeah. So we can make modifications on this that we'll make different versions depending on the specific model that we have. And I'll show you how to do all that in just a bit.
Okay.
First, we're going to go and do the line tool, which is right next to the text tool.
Yep.
And just go ahead and draw a line anywhere. Doesn't matter. Left to right. Yeah. Okay. Now hit escape. And we're going to go right click on the line. Hit escape one more time because you're still in the line tool. And properties. At the bottom. Yeah. All right. Now from and to. We can change that. Let's see what we got on my data sheet here.
This is
So
on the
I
T
think
names layer. I want to change it to probably what layer?
you want it to be T place. That's the placement. If you go back into that list, I'll actually go and explain what those are. Into the T place list. Or yeah, you can do that. Okay, so
These are
underneath
all
the
my
routes.
different layers. So if I had a multi-layer board,
Precisely.
16 layers
You can have
total,
up to-
right?
Exactly. You have up to 16 net layers. Exactly. Then we've got your pads and vias, and your unrouted, which is the rat's nest. Dimension. The dimension is your board outline. So that's what defines the shape of the board. T place is the top placement silk screen. B place bottom placement. So like origins is going to be those little crosses you see for each of the parts.
Okay.
That's what those origins are. So if you end up taking that layer and hiding it on accident, you won't be able to move anything. So yeah, T and B just top and bottom. Names and values. So the names of the parts, and then the values would be like if you wanted to print like this resistor is 100 ohms, etc. Things
Right,
like that.
right.
So then we've got our stops, and what that is the area in which the solder mask will not be placed, so that you can have pads that are exposed, things like that.
Okay.
I forget what finish is. I think finish is like if you had some sort of extra material that you had to add to specific areas, things like that. Your glue is it used to be called cream. They actually changed it to glue finally, thankfully. Because it used to be really called cream, and that was really creepy. Anyway.
No, it's up here. 31 and 32 are cream.
Oh.
Because it's cash rules everything around me, right? That's what it stands for, right? Wu-Tang taught me this years ago.
I'm not familiar with that one personally.
You don't know the song Cream? Oh, I'm disappointed in you. I
know. So anyway, so cream. I don't remember glue being there before, but I'm assuming glue is the same as cream at this point. It's basically for pick and place machines that you have to glue a part in place for whatever you're doing.
Real tiny stuff where solder paste wouldn't work.
Precisely. These ones are some of the more important ones.
Drills, holes, milling,
which is the keep out and restrict are kind of wonky to understand, but they're really important as well. Okay. So like copper keep out. So let's say you've got like one of those ESP32 chips, and it's got one of those little Wi-Fi antennas at the top of it.
You don't want copper around it because it'll be a Faraday.
Precisely. So you put the copper keep out underneath where that antenna would be to prevent the copper from being printed there. Restrict is a similar thing, but it can be overridden. It's, there's hierarchical layers to that, as far as I'm aware. So it's mainly used in power supply systems to prevent you from doing stuff like putting your data lines through it, if you're doing auto routing and stuff. But anyway, so that's what those are. The T place is where we put our board edge lines or anything to do with the placement of the part, or like if you were doing a logo, I would do it in the T place layer as well. So anyway, go ahead and right-click on that line again. We're going to change its shape by changing its locations.
Okay.
And from to, and so our from is going to be that negative 7 divided by 2 is...
What do you have to divide?
My arithmetic sucks today. 9 divided by 2 is 7, or negative 3.95. And your vertical on that is going to be 2.1. Or, yeah, 2.1.
Oh, where it says 3.81, change it to 2.1?
And then on our 2 is going to be a positive 3.95 and 2.1. Those are X and Y coordinates for each end of
and then hit apply?
2.1.
Oh, no, I don't want it on T names. Where do I, or do I want it on T names?
T place.
T place. Okay.
Then
apply.
Remember, it's 2.1 on that second.
Whoops.
Right there.
Sorry.
There you go.
Hit apply.
And apply. Yep. Oh, I did it a little bit wrong vertically somehow. What did I do wrong? Hang on. Oh, I didn't take that into account. Sorry, 2.1 plus 1.4, so 3.5. There we go.
Okay, and if I just click it, the inspector shows me all the stuff over here.
Precisely. Now, if you want, we can add a little bit more detail to that, but that's the board edge. So now we can go and hit the save button, because we're pretty much done with that bit. And label it however you like. This is your parts library it's saving. So,
what should I label it?
Osmo parts library, or Osmo electronics parts library, or something like that.
Sure. Yeah, I should save more often. But my computer just crashed yesterday, so I should be okay. It's not stable.
F360 has an autosave function.
It does. No, I'm just mad that I can't get a good stable overclock on this computer, and
Okay.
prices still haven't come back down to where I can
Okay.
and financially we've had a bit of a hard year, so whatever.
Sure. Okay, so we've done our footprint. Now we got to do the symbol. So if you go back over to that set of buttons in the top left corner, you'll see one that looks like a little guy with arms on the side. Yeah, that one. Creating a
That's
symbol.
That's a MOSFET, right? P channel or N channel MOSFET.
That's an op amp.
Oh, it's an op amp. Sorry, I'm just being an
All
asshole.
right, usable name. We're gonna do USB-C, USB-C. Dash, I think dash full, because there's some versions of that don't use all the pins.
Okay.
Okay.
I need to turn you
now,
up. Give me just a second.
Sure.
It only turns it up for me. Don't worry. It doesn't change it for anybody else.
Sure thing. So now what we're building is something called a symbol, which is the part that we add to the schematic that corresponds to the part that we just made for the footprint. So we can make a little drawing here of like the USB-C connector if we want, or we can just make a block and then add pins to it. So
I like
generally
that one.
speaking, so go ahead and hit take any of those little drawing things at the top. There's a rectangle one I particularly like. To the right a little bit more. There you go. And just make a rectangle of appropriate size. Oh, you're on symbols.
Why am I in inches?
Hit escape, and then we're gonna go and fix that whole business with the what do you call it? The grid again. I believe that's gonna be under one of those. What do you call it? The document at the very top here. Oh, maybe not. Outpost. It's going to be under one of those pull downs. It's hiding a lot of the buttons at the top at the moment. Yeah, one of those pull downs like you just did. So it's going to be under there somewhere. Be an edit. Oh, let me check on mine. Hang on. Where are you, Mister?
I'm just checking because there's all this for a line. I'm sure it's somewhere stupid, and I just don't know what I'm looking at.
I'm not seeing it either, which is strange. So give me one.
All right, whatever. We'll roll with it. Oh wait. Nope, that's not it.
If you click on that that little there's a bar next to the symbols thing that says click or press slash to activate command line mode. You just hit slash.
Where do I see that?
Down, right directly. You were just over it. Down a little bit to the right.
Ah.
Okay. Try grid. Hitting grid. Hit that.
Hey, Macarena. All right.
All right. I would also change that size to 1.72.
1.72.
A lot of symbol. A lot of symbols use the. Wait. Is it 3.25? 1.72 is the. Yes, it is. Okay.
I have tons of 2.54 JST laying around, so this is good.
Yes, you are. Yeah. This is just the schematic thing. It changes the grid for the lines and how you can build stuff. A lot of the symbols that are floating around in the world use a 1.72 pitch instead of 2.5 or 2.54, and it makes doing the line tracing kind of wonky. So I just try and make sure to change that first. Go ahead and hit OK at that point. Now, we're going to go and
rectangle.
Do instead of rectangle, do a line, because the rectangle isn't doing the right thing. If you click on the draw underneath that, they don't have lines. Okay, do poly then. Oh, there it is. There we go. Okay, and just make a rectangle of whatever size you feel like. You can change it later.
Okay.
Now go ahead and escape to end your tool usage.
Okay.
The escape key will do that for you. And then, okay, so if you want to resize that, you can. I would recommend making it a little bit smaller, because
I don't know. It's not dimension though, is it?
What you can do is if you use your selection box to grab the entire left-hand line, you can drag it over. Yeah. Start from top left and like above it. Yeah.
Nothing comes up.
You have to click and hold. Or you're not. Is it not doing it?
Yeah, I'm holding it.
Oh
Hey,
shit! It's
dude.
not. Okay. Okay. I guess maybe draw smaller. Not
Wait,
sure why it's
select.
doing that,
There's a
but-
select tool. Aha!
Okay. Hit escape again. All we want to do is to grab that left hand line, and then
This one.
the left hand line. So the entire left hand line. Go all the way down to encompass the entire thing. There you go. And now you should be able to click on that line and hold and drag it. And you can move
Oh
it to the
yeah,
right
look
so
at
it's
that.
closer
Now
to the
that's
origin.
CAD right there, baby.
So when you're clicking and holding lines in Fusion 360, there's something you have to recognize. The selection of the line is very precise. If you
Right.
if you click the line itself, it'll grab the entire line, both ends. If you use a selection box, it'll select whichever end of the line is within the selection box and ignore the other one. We'll make it change the way that, like, which vertex is being used at any particular given time.
Right.
That can be very frustrating when you're trying to move things after you've already placed them. So just keep that in mind. So anyway,
Justin
move
says
that,
I'm an idiot. I had a tool selected and needed to hit escape for the select.
So go ahead and move all the way to the right. I'd like to just get it a little bit smaller. I want to have like maybe
Like
like you see where that little X is right in the middle where
Yeah.
the origin.
A little
Like
bit
2
beyond
or 3
it.
clicks to the left of it, just a little bit, like right
Okay.
there.
I got 3.
And do the same thing for the other side. Just resize it down a smidge. Right. Okay. Cool. Now
Top
we're
and
going to be
bottom
adding.
or no? Leave those.
I would even it out at least. Like this is my OCD talking.
Dude, same though.
All right. Yeah. Whatever you like. Okay. So you don't want it to be too small because we have to add a bunch of pins. I would actually keep it a little bit higher than that, like more vertical space.
He says to make it even for the OCD and then tells me to not make it even anymore.
I
Damn
said
it.
you needed to make it more vertical. You can add more space on the bottom and make it even again. Anyway, so we're gonna be adding a total of 15 pins
What?
on this, or not 15. Sorry, 12, 13 pins. Excuse me. So there's a pin add button right next to the line button. On to the left of that.
Okay.
Now, if you scroll out a smidge, okay, you see where your that's just orientation. So if you observe, you have something that looks kind of like a little poof, like a little dandelion, if you will. You have a circle with a line.
I see a
down.
very light circle around the line. The circle, that is where the part sits, right?
Correct. So like I said, this is just a symbol. That circle is the connection point where when you start adding wires and connections, that's where that will
That's where
connect.
they go. Okay.
So, exactly. So the line now extending to the right of it is just sort of a representation of what that's attached to. So what I would do is make sure that the end of that line that doesn't have the circle on it is resting on the edge of that
Like that?
thing on the other side, other way around. You want it to be on the outside. So further to the right or the left. Yeah, just like that.
Okay. I need 12 of
And
these.
then you're going to add 12 of them total. You can do them like all on one side. You can do it however you feel like. And you want to do one on the bottom, and that's going to be our ground.
Dude, I had it the perfect size.
Yes, you did. All right, so if you right click, it'll rotate,
Oh, okay.
or you can do that.
Like that?
And then, yeah, just stick it on the bottom. Yeah. All right, cool. Now, we're going to do the same thing we did before, which is naming these pads.
Oh, jeez.
We're going to name them a slightly different.
Should I click OK?
Before, because or escape. Yeah. All right, so we're going to be doing in this case is we're naming the pads according to the nets or what signals they're going to be carrying instead of it doing it by the pad associations. Before we were doing the pad names and numbers. This time we're going to be doing the nets or the signals.
Okay.
Let me go back over to the data sheet real quick and I'll read them off to you. Okay, so our pin 1 is going to be ground. So just GND.
Okay.
And pin 2 is going to be TX1 plus. Actually, let's do TX1_P. I'll explain why in just a second. So,
Okay.
And then we're going to be doing TX1_N.
Hello?
You need to click on the circle.
Oh, okay.
The connection point acts as the origin for pins. Next one, N, good. Now our next one is VBus. And in the direction there's a pull down on there that says direction. You see that? Go ahead and change that to IO, or from IO to power, PWR.
Okay.
And next we've got CC. And then we've got D_P.
Oh, got it. Moved.
And next one's D_N.
N as in November.
Correct. Yeah, so that's our data, positive and negative. Next one is SBU1. We're just going to do SBU, excuse me.
Okay.
And then we're going to do VBus again. Do VBus 0 because we need a unique name.
And change the
And again,
direction of
change that.
power again.
Perfect. And then we've got RX2N, RX2_N. And then RX2_P. And the last one's ground as well, so GND0.
Okay.
And then lastly, we're going to be actually, you know what? You go ahead and take that last pin off. You don't actually need it. We can do this in the connections.
This is the case, right?
Precisely.
Okay.
We can, if you want, we can leave it in. You can say tab, or you can say.
We'll do tab.
Case or
We'll leave
shield.
it in. Let's leave it in.
Okay, cool. Now, go ahead and hit save on that as well. Okay. Right now, we've gotten our footprint and our symbol. Now we actually create the part itself, and that's going to be the far left add button.
Far left. So create new device. Yeah.
That's the one.
Okay.
Now we get to name it, and just do USB-C. Okay. Now, so this is where everything comes together. I would actually go ahead and minimize that inspector window on the right. Now we're going to go and there's a at the very top next to the layers thing, there's a little button that looks like another add thingy to the right of it. More right. There you go. Add part. There you go. USB-C.
Hey, I know that part. We made that
Go ahead and
part.
place it. Yeah, we did. Go ahead. I would place it at the origin.
Like that in the center, or do you want the bottom?
Or put your cursor over the other cursor that's there. Yeah, there you go. Now, go ahead and hit escape again.
Okay.
And now we're going to go in the lower right-hand corner. First thing I want to do is actually change the prefix. So go ahead and click that first. That's going to be C for connector, or you can do J for jack. Sorry, not C. It should be J because C is usually. Sorry, wait for it. All right,
Okay.
cool. Now we're going to do right above that prefix button is a new, and do add local package. There you go.
Hey.
That's the one.
Hey.
And go ahead and expand that out a little bit. If you put your cursor over the interface between the main window you're looking at and that sidebar, it'll come up with a little thing that'll let you
Here?
sort of expand it. To the right, there you go. That's
Oh,
the one.
you want
Right.
this out?
Perfect. Yeah, just a little bit. And go ahead and hit the connect button on there because you notice that under mapped, you see that little exclamation says it's not there. So now we get to connect the pads, the pin names with the nets to the pad names. We're going to start with A1. That's going to be our ground. GND.
This one here.
Yeah.
Okay. Connect.
Connect. And now, before you do anything else, scroll down on the pads on the right hand side, or in the middle window, and B1. Hit append.
Append.
Both of those pins are connected to the same net.
Okay.
now we can actually, if we only wanted to have one ground pin on our symbol, we could technically connect all the grounds to that by itself, but we didn't. We have more pins. So we're going to be going through. We can do it either from top to bottom in the pin side or the pad side. Which direction you want to go with it?
Whatever's best for you.
You got ground 0 connected. That's going to be A12 and B1.
Yep. So we'll connect that, and then wait, B1.
Sorry, B12. Excuse me, A12 and B12.
Okay,
I'll
A12
just,
and
you want
B12, and that's
those.
the append, and that gets it to add to it.
Precisely.
Okay. All right. All right.
So, and then we've got our PC is going to be A5 and 5.
B5, right?
A5, B5. Well, yeah, B5 has a different connection. Oh, okay, that's it. Yeah, yes, it is. I forgot. Their data sheet just has a weird notation on it.
A5, B5?
5B5. And their next one is DN is going to be A7, B7,
Okay.
and P is A6 and B6.
Okay.
And then we've got.
This is why I pay electrical engineers. This is a real pain in the ass. No wonder this stuff takes forever.
It takes forever, and it takes a lot of money. So anyway,
Yeah.
A11 and B11 is RX2. Oh wait, so that was the negative. My bad. Hit the disconnect on there. There you go. Negative is A10 and B10. My bad.
So that would have been bad news bears had we actually done that. The negative, or the positive is the 11 and 11, right?
Correct.
Okay. Yeah, that would have been bad, right? Although, I guess for what we're doing, it probably won't matter. I only really just need to feed it power and ground. That's all I need to feed
it won't matter on the data pins very much. Yeah, SPU is going to be 8. 8.
A8?
8 and B8, yeah.
Okay.
Right. And we've got tabs. That's going to be your tab.
It's these, right? The ground 1, 2, 3
I
grounds.
think it's going to be yeah. Exactly. So yeah, all those, just append them all in. Perfect.
Okay.
All right. TX1. Negative is A3 and B3.
Oh,
And then
shit.
we've got
I messed
8.
up. Sorry.
It happens. That happens. Hey, that works too.
Connect all that. So
TX1,
that's A3
negative is
and B3.
B3, yeah. Yep. And then that's your A2 and B2.
V
You got
bus
V-bus
is
on
4s, right?
4 and 9. All 4 of those. Or actually, you're right. I forgot we did the different pins there. Good, yeah.
Okay.
Right, okay, that's it.
Now everything's
if we-
connected, so now it kind of has an idea. Normally, we would not have to do this, right? It's like traditionally, this is not something we have to do.
Only if you have all the parts that you need in a Needle library already. So,
Okay.
this is.
But since we don't have a library, we don't have any of the parts that we need because they don't exist and nobody has them in stock because the whole world is just having problems right now. We have to do it ourselves.
Precisely. Now, I would go and save one more time.
Love it.
Later on, if we go and find a 3D model for this, we can add that as well. But we'll just leave that for now.
Yeah.
All right, go back over to our schematic. That tab at the top says Untitled.
Okay.
Oh, okay, that's the full library. My bad. This is the one on the right-hand side. There
Okay.
you go. Now we're gonna go and add a part right under this the same looking button that you just pressed earlier. It's under the library section next to the move button. Left a little bit. There's the arrows in a cross, and it's to the left of that button there. Next to place. It's directly under where it says library.
Directly under library. Okay.
There you go. Add
Yep.
part.
Add
There you
part. Hey, got him. All right.
So now, you need to find your library that we just made, which should be visible. Hey, Osmo EE library right there.
Okay.
And go ahead and expand that. You see? All right. Hit OK.
Hit okay. Oh!
Now place it somewhere.
Hey, we got it.
Okay. Go ahead and escape. All right, now if you want to see it actually on the board or something like that, we can hit that little switch to PCB up there. Yeah, it's going to create one for us. It's got a basic outline, and your part's going to be sort of to the left underneath the origin.
Oh, it's boring. I can't see it. That's okay.
If you move it over to the gray area, you will be able to a lot better. If you grab that cross is what you need, what you want to be aiming for. Origin in every case is what you should be trying to click on instead of doing selections.
Oh, okay. Sorry.
That's okay. Just FYI for future, because that'll save you a lot of headaches.
Okay. I'm gonna switch back to schematic.
And now we're gonna go in. Let's go ahead and add that diode like we were talking about, so we can have some basic protection. Go back into the parts ad. And what I would do is under the search bar. Yeah, you can do that too if you want.
Is that the Shocky diode?
It is. Yeah, perfect.
Oh, but see, can we get ones that are through hole maybe?
Yeah, sure. If you go up from that on the selection, there's a further pull down that says diode.
Yep.
IN 4148s are pretty good. SOD still. You want to keep looking. They should be. If you just use the arrows, you can actually like scroll through them a little bit quicker.
Oh wait, that's through hole. No,
it's not through hole. It's surface mount. No, it's not.
Oh god,
it's just
terrible.
a round surface mount.
Oh no, why would anybody want a round surface mount diode? Yeah, those
They're
are
actually pretty efficient. If you go up to the one above that, yeah, try that.
That's not the diodes we're looking for. These are not the diodes you are looking for.
Are you sure? There's a 502. Oh, it's the hang on. 215s. Yeah, those are all SMDs. Okay. So yeah, go down to the search bar if you don't mind.
Sure.
And just do star. Star.
Do I just want to look up the IN 4148?
Sure. Try. It's one N, by the way. You want the stars. You need those asterisks before and after, otherwise it'll like ignore stuff. You need the wild cards because it's a very strict regex for this search. It's the only one in the library. Okay, so this is a perfect opportunity for us to show how to find a library on the web and import it.
Done. Let's do it.
Two ways of doing this. The simple but possibly wrong way is to go to Open Library Manager right there. And go to Available again. You can like search through this. We might be able to find something, but like maybe. I'm pretty sure that the Adafruit library has something in it.
I was gonna find like DigiKey, and then I was gonna look.
That doesn't.
I want
doesn't
all
happen.
of. There's diode library.
There are, but we don't really know what's in it. I think I'm pretty sure that the Adafruit library has a through hole.
It's Adafruit. They're gonna have it. Like
that's one easy way of trying to find parts is going through what's available on like the library.
I should install the libraries that are bundled with Fusion 360, shouldn't I?
No, that was a thing. Yeah, let's try it. Anyway, in the meantime, leave this sort of in the background.
It didn't say it said it going to be loaded. Okay.
Okay, wait, fine. Leave that where it is for the most. Actually, go back into Library Manager. Leave it there for a moment. Let's go and open up a web page. Let's go to SnapEDA.
Just trying to see if I have them open, so I don't have to open up another damn tab.
Hey, let's switch to tab. That's fine. All right. So yeah, then just stick in your 1N4148. Okay.
There we go.
Now, there you go. So you'll notice that that particular one on the data available column shows it's got both the datasheet symbol, the footprint, and the 3D package.
Well,
so go ahead and grab that.
This one's not going to work. It's only 0.15 amps. We got to have higher current handling.
Doesn't matter. We can buy one that fits the same footprint that does better current.
Oh. Okay.
Ignore the actual ratings because a lot of parts that are through hole are very interchangeable.
So I want symbol.
So we're going to do the symbol and the footprint. Symbol and footprint, right? Then we're going to go to Eagle.
Eagle.
Hmm. Oh,
get your butt! Damn it, Bobby!
God damn it! I forgot about that.
I'll be right back.
All right,
I'm blanking. I'm gonna blank my screen. It's fine.
Okay. I forgot that they make you sign in.
Ah!
Unfortunate that almost
I can
all
sign
the
up
good
using
tab
Twitter.
sources.
I don't know. Do I want to sign up using Twitter?
It's not like it's going to be that bad. It's a professional site. They've never sent me spam.
I'm just gonna sign up through email. It's fine.
Okay. Yeah. It's kind of unfortunate that there's walled gardens for the best stuff, but it really is the best stuff.
I stop with all the. There's so many pop-ups. All right, let me unblank this. All right, we have Eagle.
Uh-huh.
Dang it! I'll be right back again. Ah, I didn't think it was gonna need a validation email, but no. Everything needs to be validated. I want to be validated.
I'm trying to validate you. Did you feel validated?
I do have a hard stop in about 10 minutes though.
Cool.
So that will be the
almost
end.
Done with this part of it.
That will be the end of the stream
revisit.
today in 10 minutes. All right.
We can pick it up later. That's fine.
Oh, we got it.
Okay, cool. Did we? All right. So, where did it download to?
It downloaded to my downloads right here.
Okay, fine. Cool. So go back over to Fusion 360.
Okay.
Our library manager. We're going to go back to in use now. Perfect. We're where we need to be. Go ahead and hit browse.
Browse. Okay. Done.
Lost you.
You lost me.
Yeah. I don't know. Maybe there's an issue on my end, but
I got it.
Lost video for a second.
We're in like sin.
All right. Cool. Now the go ahead and close that now. And what I would suggest we do before we actually add it is actually hit cancel on there. Go back to your library, the tab. Osmo EE library at the top there. Okay.
Oh, that one. Okay.
Now we're going to go and actually import a part. So if you go to the top right-hand side and add a part again. Right, or far left rather. Yeah, create a new device. And we're going to import. There's the import button right there. And go ahead and, yep. Boom.
Okay.
Save it again. And since it's that's in our library, we can now control the various different attributes of this device to our satisfaction. We don't have to use the one that it came imported with.
Gotcha. So if we need to change some things, we can go back here, and then it will auto update to the other thing, right?
Precisely, exactly. And when that way we're not beholden to whoever else's library gets updated and changes on us.
Good. We don't want to, I don't need no man. That's right.
We don't want what you don't want is unexpected footprint changes when you're using the same parts and shit later on. So
yeah, that'd be not great.
So yeah, anyway, back over to our design tab, or you were in it. There's the design section of the menu at the top there.
Okay.
And now we can go ahead and add that part.
I gotta add the part. I gotta add.
We're gonna do it from not from there. You want to do it from your library, the Osmo EE library.
Oh,
have it
okay.
right there in the list.
Ah, because then of course we're controlling it.
Precisely.
Okay.
Yeah. I would set that as a vertical between just like next to it.
Like that.
Precisely. And now, what we're gonna do. Actually, you should add two of those. My bad. We're going to be using these for two different things. One is going to be reverse voltage protection,
right?
And the other one is going to be for just making sure that the like it's a pretty much impossibility. But if you ended up somehow wiring the input backwards, then it will take care of that as well. So
thanks.
So what we're going to do is there's a line tool up at the top that looks like a little like kind of corner edge one. That one's a net. Yeah, that's it. So that allows us to add wires. And what we're going to do is we're just going to take from the top of that one, and going to stick that on to the V-bus pin.
Okay.
And then I would say for the V-bus 0, also grab from there. You cape on that. V-bus pin.
V-bus or V-bus
V-bus
0?
0.
Okay.
You need both of them on it. Okay, and then just like up to connect it. No. Just connect it to the same pin there. There you go. This is see that weirdness is going on right now. That's due to that gridding error. So go ahead and switch your grid back to 1.75 millimeter. Yeah, it's yeah.
Grant forgets how to do that.
The grid is up next to the view document stuff in the top of the bar. To the left, there's a little grid there. There you go. And then, yeah, change the millimeter, 1.75.
So that's 1.27, right?
Yes, yeah, 1.72, exactly, my bad.
Okay, so we want to come now off of, grab this, come off of V-bus, up, well.
It's still having some weird spacing. Oh! That was because we screwed up the spacing when we made the symbol. So go ahead and hit Control Z on that. Control Z one more time. Okay. Now what we're going to do is right click on the origin for that connector, which is that little X next to the right in the center. Right click on that. Yeah, your mouse was right over for the connector, not for the diode. We're going to go to Open Symbol. It's a little shortcut to get where we're going. Now let's go ahead and fix that grid again. You're gonna have to type it in this time, I think. Remember that little bar that says press? It's the terminal bar that's right next to, is right above the window, or the aperture, if you will.
Here?
Yeah, that's the one. Yep, and then type grid and hit enter. Or that.
Yep, there it is.
It's 1.27. Got my dyslexia getting at me the other day. Okay, so now what we're going to do is just click, hold, and drag each of those pins till they snap. Snap to a new location. Oh, shit.
They're still snapping to the same location.
They are, because they start at the current... yeah, okay. They changed that. There was a trick you could do back in the day, because their UI was a little bit actually more borked, where you could change the grid size and then snap it to that new grid. It looks like they changed it now so that the grid is now relative rather than absolute. Which means that we have to manually change the positions on those annoyingly. Or we can delete and restart.
No, we're not doing that.
Okay.
We're not doing that.
Unfortunately, this may be beyond the time we have for today then.
Yeah.
Because you're going to have to go and change the from and or the locations for each of those.
Seriously, I got to go back and do this manually.
Because we screwed up the grid there, yes, unfortunately.
Holy shit.
This is why it's important to get that grid right, and I'm really sorry that I had my
No,
own
it's just
dyslexia
frustrating that it's CAD. Why doesn't it just auto update the size?
Because it's CAD that's designed to work with everything, and so you have to kind of know what you're doing.
All right.
So, like, because I set the pitch wrong, it's trying to preserve that customization that I did.
So can I just
you right click
come
on
here
that,
and do properties?
Actually, what I would do is just actually here's what we'll do. Cancel that. Select all of the pins. And open your inspector again. The right hand side.
Working on it.
No, not the bottom pin, just the side pins. My bad. I have to control click it. Oh yeah, that works. That'll do. All right, now inspector.
Okay.
And then your position on the right hand side, that one, just sit 0, and then we can drag them into place. Now we can hit escape, and you should be able to just click on that pile of pins and drag them out, and we'll position them as needed. Yeah, just put that one at the top. We'll fix the box in a second. RX2P. Yep, that's in the right order at the moment. All good. Where you gotta grab the circle. There you go. Bus 0. Yep. SBU. Yep. All good. All good. I think when we reach that line, then we're gonna start going in reverse.
Yep.
Yes, sir.
No, that's it.
That's the end of it.
Oh, because they're much closer
great.
now.
Yeah, so if you want to spread those out, you might want to give it a little bit of space as far as the pins, so they're not. You remember, you got to grab the edge. There you Just give them like a little bit of room. And
Well,
then you're gonna start
that was gonna work out well,
evolving.
and then it didn't.
Okay, we can always adjust it. You can do more down too if you like.
That's all right. I don't understand why this main box isn't.
Because we haven't reset the grid on that one yet. It's still on that old custom grid.
Okay. I do have to go.
Which I would just. Yeah. What I would do to be fast about this is delete the old box and redraw it.
Gotcha. Okay. Yeah, that's fair. We can do
Yeah.
that.
Yeah. You gotta hop off. We can pick this up whenever is next.
Yeah. We'll schedule something for later in the week when you actually have time, or we can do this next week. I don't know. It's up to you. I don't want you to, because like, I'm the one that needs help, so I don't want to like, say, well, I need you here at this time.
I know, but I'm having fun, so we'll figure it out.
All right.
And I'm definitely interested in getting this design sorted out with you, because easy basic. I would make sure you go and save all that.
Oh yeah, I'm gonna save it right the frig now. So many saves all the time. Well, all right.
The other bits as well are still showing as untitled.
Oh, we didn't do anything with these.
Yes, you did.
Oh.
Save and you'll see. Might want to name it.
That's okay. It's under Osmo Accessories, so we're fine.
Yeah, watch what happens. Should update it. There it goes.
Well, I'm gonna end this thing. I appreciate everyone for hanging out for now 3.5 hours. It's the way it goes sometimes. We're gonna pick this up, I guess, either later this week, next week, who the hell knows. We'll let you know. Make sure you get subscribed, leave a like on this video, and we'll see you guys in the next one. Don't forget to call your loved ones and stay safe out there. Have a good one.
Good one, guys. See ya.
Bye. There, now you get Crab Rave to end off too. Thanks for hanging, everybody. This one was a bit of a pain, but I'm glad everyone hung out and we made it work.